Wikipedia News Edition, Season 1 Remastered.
On 6th episode is Google Chrome.
Google Chrome is a web browser developed by Google.
It was first released in 2008 for Microsoft Windows, built with free software components from Apple WebKit and Mozilla Firefox.
Versions were later released for Linux, macOS, iOS, and also for Android, where it is the default browser.
The browser is also the main component of ChromeOS, where it serves as the platform for web applications.
Most of Chrome's source code comes from Google's free and open source software project Chromium, but Chrome is licensed as proprietary freeware.
WebKit was the original rendering engine, but Google eventually forked it to create the Blink engine. All Chrome variants except iOS use Blink as of 2017.
As of April 2024, StatCounter estimates that Chrome has a 65% worldwide browser market share after peaking at 72.38% in November 2018. On personal computers, PC is most used on tablets, having surpassed Safari, and is also dominant on smartphones.
With a market share of 65% across all platforms combined, Chrome is the most used web browser in the world today.
Google Chief Executive Eric Schmidt was previously involved in the browser wars, a part of U.S. corporate history, and opposed the expansion of the company into such a new area.
However, Google co-founders Sergey Brin and Larry Page spearheaded a software demonstration that pushed Schmidt into making Chrome a core business priority, which resulted in commercial success.
Because of the proliferation of Chrome, Google has expanded the Chrome brand name to other products.
These include not just ChromeOS but also Chromecast, Chromebook, Chromebit, Chromebox, and Chromebase.
Google Chief Executive Eric Schmidt opposed the development of an independent web browser for 6 years.
He stated that, at the time, Google was a small company and he did not want to go through bruising browser wars.
Company co-founders Sergey Brin and Larry Page hired several Mozilla Firefox developers and built a demonstration of Chrome.
Afterwards, Schmidt said, "It was so good that it essentially forced me to change my mind."
In September 2004, rumors of Google building a web browser first appeared.
Online journals and U.S. newspapers stated at the time that Google was hiring former Microsoft web developers, among others.
It also came shortly after the release of Mozilla Firefox 1.0, which was surging in popularity and taking market share from Internet Explorer, which had noted security problems. Chrome is based on the open source code of the Chromium project.
Development of the browser began in 2006, spearheaded by Sundar Pichai.
Chrome was largely developed in Google's Kitchener office. The release announcement was originally scheduled for September 3, 2008, and a comment by Scott McCloud was to be sent to journalists and bloggers explaining the features within the new browser.
Copies intended for Europe were shipped early, and German blogger Philip Lenson of Google Blogoscope made a scanned copy of the 38-page comic available on his website after receiving it on September 1, 2008.
Google subsequently made the comic available on Google Books and mentioned it on their official blog along with an explanation for the early release.
The product was named Chrome as an initial development reject code name because it is associated with fast cards and speed.
Google kept the development project name as the final release name, as a cheeky or ironic moniker, as one of the main aims was to minimize the user interface Chrome. The browser was first publicly released, officially as a beta version, on September 2, 2008, for Windows XP and newer, and with support for 43 languages, and later as a stable public release on December 11, 2008.
On that same day, a CNET news item drew attention to a passage in the Terms of Service statement for the initial beta release, which seemed to grant to Google a license to all content transferred via the Chrome browser.
This passage was inherited from the general Google Terms of Service.
Google responded to this criticism immediately by stating that the language used was borrowed from other products and removed this passage from the Terms of Service.
Chrome quickly gained about 1% usage share.
After the initial surge, usage share dropped until it hit a low of 0.69% in October 2008.
It then started rising again, and by December 2008, Chrome again passed the 1% threshold.
In early January 2009, CNET reported that Google planned to release versions of Chrome for macOS X and Linux in the first half of the year.
The first official Chrome OS X and Linux developer previews were announced on June 4, 2009, with a blog post saying they were missing many features and were intended for early feedback rather than general use.
In December 2009, Google released beta versions of Chrome for OS X and Linux.
Google Chrome 5.0, announced on May 25, 2010, was the first stable release to support all three platforms. Chrome was one of the 12 browsers offered on browserchoice.eu to European Economic Area users of Microsoft Windows in 2010. Chrome was assembled from 25 different code libraries from Google and third parties such as Mozilla's Netscape Portable Runtime, Network Security Services, and the API, dropped as of version 45. Steam Graphics Engine, SQLite, and a number of other open source projects.
The V8 JavaScript virtual machine was considered sufficiently important project to be split off, as was Adobe/Mozilla's TaBNWNE, and handled by a separate team in Denmark coordinated by Lars Beck.
According to Google, existing implementations were designed for small programs where the performance and interactivity of the system weren't that important, but web applications such as Gmail are using the web browser to the fullest when it comes to DOM manipulations and JavaScript, and therefore would significantly benefit from a JavaScript engine that could work faster. Chrome initially used the WebKit rendering engine to display web pages.
In 2013, they forked the web core component to create their own layout engine, Blink.
Based on WebKit, Blink only uses WebKit's web core components while substituting other components, such as its own multi-process architecture, in place of WebKit's native implementation.
Chrome is internally tested with unit testing, automated testing of scripted user actions, fuzz testing, as well as WebKit's layout tests. 99% of which Chrome is claimed to have cached and against commonly accessed websites inside the Google index within 20 to 30 minutes.
Google created Gears for Chrome, which added features for web developers typically relating to the building of web applications, including offline support.
Google phased out Gears as the same functionality became available in the HTML5 standards.
In March 2011, Google introduced a new, simplified logo to replace the previous 3D logo that had been used since the project's inception.
Google designer Steve Rura explained the company reasoning for the change, since Chrome is all about making your web experience as easy and clutter-free as possible. We refreshed the Chrome icon to better represent these sentiments. A simpler icon embodies the Chrome spirit to make the web quicker, lighter, and easier for all.
On January 11, 2011, the Chrome product manager, Mike Jazzieri, announced that Chrome would remove H.264 video codec support for its HTML5 player, citing the desire to bring Google Chrome more in line with the currently available open codecs available in the Chromium project, which Chrome is based on.
Despite this, on November 6, 2012, Google released a version of Chrome on Windows which added hardware accelerated H.264 video decoding.
In October 2015, Cisco announced that it was open sourcing its H.264 codecs, and it would cover all fees required. On February 7, 2012, Google launched Google Chrome Beta for Android 4.0 devices.
On many new devices, with Android 4.1 and later pre-installed, Chrome is the default browser.
In May 2017, Google announced a version of Chrome for augmented reality and virtual reality devices. Google Chrome features a minimalistic user interface, with its user interface principles later being implemented into other browsers.
For example, the merging of the address bar and search bar into the Omnibox or Omnibar Chrome also has a reputation for strong browser performance.
The first release of Google Chrome passed both the ACID 1 and ACID 2 tests.
Beginning with version 4.0, Chrome has passed all aspects of the ACID 3 test.
As of May 2011, Chrome has very good support for JavaScript/ECMAScript according to ECMA International's ECMAScript Standards Conformance Test 262, version ES 5.1 May 18, 2012.
This test report says the final score the number of tests a browser failed, hence lower scores are better.
In this test, Chrome version 37 scored 10 failed/11,578 passed.
For comparison, Firefox 19 scored 193, failed/11,752, passed, and Internet Explorer 9 has a score of more than 600, failed, while Internet Explorer 10 has a score of 7 failed.
In 2011, on the official CSS 2.1 test suite by standardization organization W3C, WebKit, the Chrome rendering engine passes 89.75%, 89.38% out of 99.59% covered CSS 2.1 tests. On the HTML5 Web Standards test, Chrome 41 scores 518 out of 555 points, placing it ahead of the 5 most popular desktop browsers.
Chrome 41 on Android scored 510 out of 555 points.
Chrome 44 scored 526, only 29 points less than the maximum score. By default, the main user interface includes back, forward, refresh / cancel and menu buttons.
A home button is not shown by default, but can be added through the settings page to take the user to the new tab page or custom home page.
Tabs are the main component of Chrome's user interface and have been moved to the top of the window rather than below the controls.
This subtle change contrasts with many existing tab browsers which are based on Windows and contain tabs.
Tabs, with their state, can be transferred seamlessly between window containers by dragging.
Each tab has its own set of controls, including the Omnibox.
The Omnibox is a URL box that combines the functions of both the address bar and search box.
If a user enters the URL of a site previously searched from, Chrome allows pressing tab to search the site again directly from the Omnibox.
When a user starts typing in the Omnibox, Chrome provides suggestions for previously visited sites based on the URL or in-page text. Popular websites not necessarily visited before, powered by Google Instant and popular searches.
Although Instant can be turned off, suggestions based on previously visited sites cannot be turned off.
Chrome will also autocomplete the URLs of sites visited often.
If a user types keywords into the Omnibox that do not match any previously visited websites and presses enter, Chrome will conduct the search using the default search engine.
One of Chrome's differentiating features is the new tab page, which can replace the browser home page and is displayed when a new tab is created.
Originally, this showed thumbnails of the 9 most visited websites, along with frequent searches, recent bookmarks, and recently closed tabs, similar to Internet Explorer and Firefox. With Google Toolbar or Opera Speed Dial.
In Google Chrome 2.0, the new tab page was updated to allow users to hide thumbnails they did not want to appear. Starting in version 3.0, the new tab page was revamped to display thumbnails of the 8 most visited websites.
The thumbnails could be rearranged, pinned, and removed.
Alternatively, a list of text links could be displayed instead of thumbnails.
It also features a recently closed bar that shows recently closed tabs and a tips section that displays hints and tricks for using the browser.
Starting with Google Chrome 3.0, users can install themes to alter the appearance of the browser.
Many free third-party themes are provided in an online gallery accessible through a Get Themes button in Chrome's options.
Chrome includes a bookmarks submenu that lists the user's bookmarks, provides easy access to Chrome's bookmark manager, and allows the user to toggle a bookmarks bar on or off. On January 2, 2019, Google introduced native dark theme for Chrome on Windows 10. In 2023, it was announced that Chrome would be completely revamped. Using Google's Material You Design language, the revamp would include more rounded corners. Chrome colors, being swapped out for a similar dynamic color system, introduced in Android 12, a revamped address bar, new icons and tabs, and a more simplified three-dot menu. Starting with Google Chrome 4.1, the application added a built-in translation bar using Google Translate.
Language translation is currently available for 52 languages.
When Chrome detects a foreign language other than the user's preferred language set during the installation time, it asks the user whether or not to translate. Chrome allows users to synchronize their bookmarks, history, and settings across all devices with a browser installed by sending and receiving data through a chosen Google account, which in turn updates all signed-in instances of Chrome.
This can be authenticated either through Google credentials or sync passphrase.
For web developers, Chrome has an element inspector, which allows users to look into the DOM and see what makes up the web page. Chrome has special URLs that load application-specific pages instead of websites or files on disk.
Chrome also has a built-in ability to enable experimental features.
Originally called About Column Labs, the address was changed to About Column Flags to make it less obvious to casual users. The desktop edition of Chrome is able to save pages as HTML with assets in an underlined files subfolder or as unprocessed HTML-only document.
It also offers an option to save in the HTML format.
Chrome allows users to make local desktop shortcuts that open web applications in the browser.
The browser, when opened in this way, contains none of the regular interface except for the title bar, so as not to interrupt anything the user is trying to do.
This allows web applications to run alongside local software, similar to Mozilla Prism and Fluid. This feature, according to Google, would be enhanced with a Chrome Web Store, a one-stop web-based web applications directory which opened in December 2010. In September 2015, Google started making Chrome apps for your desktop.
This meant offline access, desktop shortcuts, and less dependence on Chrome. Apps launch in a window separate from Chrome and look more like native applications.
Announced on December 7, 2010, the Chrome Web Store allows users to install web applications as extensions to the browser, although most of these extensions function simply as links to popular web pages or games. Some of the apps like SpringCAD do provide extra features like offline access.
The themes and extensions have also been tightly integrated into the new store, allowing users to search the entire catalog of Chrome extras.
The Chrome Web Store was opened on February 11, 2011, with the release of Google Chrome 9.0. Chrome Web Store is Google's online store for its Chrome web browser.
As of 2022, Chrome Web Store hosts about 123,000 extensions and 29,000 themes.
Chrome Web Store was publicly unveiled in December 2010 and was opened on February 11, 2011, with the release of Google Chrome 9.0.
A year later it was redesigned to catalyze a big increase in traffic across downloads, users, and total number of apps.
As of June 2012, there were 750 million total installs of content hosted on Chrome Web Store. Some extension developers have sold their extensions to third parties who then incorporated adware.
In 2014, Google removed 2 such extensions from Chrome Web Store after many users complained about unwanted pop-up ads.
The following year, Google acknowledged that about 5% of visits to its own websites have been altered by extensions with adware. Malware remains a problem on Chrome Web Store.
In January 2018, researchers from security firm Iceberg found 4 malicious extensions with more than 500,000 combined downloads.
In February 2021, Google blocked the Great Suspender, a popular extension with 2 million users after it was reported that malicious code was added to it. Chrome used to allow extensions hosted on Chrome Web Store to also be installed at the developer's website for the sake of convenience.
However, this became a malware vector, so it was removed in 2018.
Browser extensions are able to modify Google Chrome.
They are supported by the browser's desktop edition, but not on mobile.
These extensions are written using web technologies like HTML, JavaScript, and CSS.
They are distributed through Chrome Web Store, initially known as the Google Chrome Extensions Gallery.
Some extensions focus on providing accessibility features.
Google Tone is an extension developed by Google that when enabled can use a computer's speakers to exchange URLs with nearby computers. With an internet connection that has the extension enabled as well.
On September 9, 2009, Google enabled extensions by default on Chrome's developer channel and provided several sample extensions for testing.
In December, the Google Chrome Extensions Gallery beta began with approximately 300 extensions.
It was launched on January 25, 2010, along with Google Chrome 4.0, containing approximately 1,500 extensions. In 2014, Google started preventing some Windows users from installing extensions not hosted on the Chrome Web Store.
The following year, Google reported a 75% drop in customer support help requests for uninstalling unwanted extensions, which led them to expand this restriction to all Windows and Mac users.
In October 2018, Google announced a major future update to Chrome's extension API, known as Manifest v3, in reference to the manifest file contained within extensions.
Manifest v3 is intended to modernize the extension architecture and improve the security and performance of the browser. It adopts declarative API'(S2), decrease the need for overly broad access and enable more performant implementation by the browser, replaces background pages with feature-limited service workers to reduce resource usage and prohibits remotely hosted code.
Google faced a criticism for this change, as, in the case of ad blockers, it limits the number of rules that may be set and the types of expressions that may be used.
Additionally, the prohibition of remotely hosted code will restrict the ability for ad blocking filter lists to be updated independently of the extension itself.
See the corresponding section for more details over the criticism of the Manifest v3 change. Notable examples are AdBlock Plus, AdBlock for Chrome, Cut the Rope, Dropbox, Evernote Web, Facebook Messenger, Gustory, Google Maps, HTTPS Everywhere, discontinued. Pandora Radio, Pixel Express, Privacy Badger, Streamless, discontinued. TweetDeck, StopTony Live, discontinued. A new block origin. The JavaScript virtual machine used by Chrome, the V8 JavaScript engine, has features such as dynamic code generation, hidden class transitions, and precise garbage collection. In 2008, several websites performed benchmark tests using the SunSpider JavaScript benchmark tool as well as Google's own set of computationally intense benchmarks, which include ray tracing and constraint solving.
They unanimously reported that Chrome performed much faster than all competitors against which it had been tested, including Safari for Windows, Firefox 3.0, Internet Explorer 7, Opera, and Internet Explorer 8.
However, on October 11, 2010, independent tests of JavaScript performance, Chrome has been scoring just behind Opera's Presto engine since it was updated in version 10.5. On September 3, 2008, Mozilla responded by stating that their own TraceMonkey JavaScript engine, then in beta, was faster than Chrome's V8 engine in some tests.
John Razig, Mozilla's JavaScript evangelist, further commented on the performance of different browsers on Google's own suite, commenting on Chrome's decimating of the other browsers, but he questioned whether Google's suite was representative of real programs.
He stated that Firefox 3.0 performed poorly on recursion-intensive benchmarks, such as those of Google, because the Mozilla team had not implemented recursion tracing yet. 2 weeks after Chrome's launch in 2008, the WebKit team announced a new JavaScript engine, Scrollfish Extreme, citing a 36% speed improvement over Chrome's V8 engine. Like most major web browsers, Chrome uses DNS prefetching to speed up website lookups, as do other browsers like Firefox, Safari, Internet Explorer, called DNS pre-resolution, and an Opera as a user script, not built-in. Chrome formerly used their now deprecated SPDY protocol instead of only HTTP when communicating with servers that support it, such as Google services, Facebook, Twitter.
SPDY support was removed in Chrome version 51.
This was due to SPDY being replaced by HTTP/2, a standard that was based upon it. In November 2019, Google said it was working on several speed badging systems that let visitors know why a page is taking time to show up.
The variations include simple text warnings and more subtle signs that indicate a site is slow.
No date has been given for when the badging system will be included with a Chrome browser. Chrome formerly supported a data saver feature for making pages load faster, called light mode.
Whoa!
Previously, Chrome engineers Adi Osmani and Scott Little announced light mode would automatically lazy load images and frames for faster page loads.
Light mode was switched off in Chrome 100, citing a decrease in mobile data costs for many countries. Chrome periodically retrieves updates of 2 blacklists, one for phishing and one for malware, and warns users when they attempt to visit a site flagged as potentially harmful.
This service is also made available for use by others via a free public API called Google Safe Browsing API.
Chrome uses a process allocation model to sandbox tabs.
Using the principle of least privilege, each tab process cannot interact with critical memory functions. For example, OS memory, user files, or other tab processes similar to Microsoft's protected mode used by Internet Explorer 9 or greater.
The sandbox team is said to have taken this existing process boundary and made it into a jail.
This enforces a computer security model whereby there are 2 levels of multi-level security, user and sandbox, and the sandbox can only respond to communication requests initiated by the user.
On Linux, sandboxing uses the second mode. In January 2015, Torrent Freak reported that using Chrome when connected to the internet using a VPN can be a serious security issue due to the browser's support for WebRTC. On September 9, 2016, it was reported that starting with Chrome 56, users will be warned when they visit insecure HTTP websites to encourage more sites to make the transition to HTTPS. On December 4, 2018, Google announced its Chrome 71 release with new security features, including a built-in ad featuring system.
In addition, Google also announced its plan to crack down on websites that make people involuntarily subscribe to mobile subscription plans.
On September 2, 2020, with the release of Chrome 85, Google extended support for secure DNS in Chrome for Android.
DNS over HTTPS, though, was designed to improve safety and privacy while browsing the web.
Under the update, Chrome automatically switches to DNS over HTTPS, though, if the current DNS provider supports the feature. Since 2008, Chrome has been faulted for not including a master password to prevent casual access to a user's passwords.
Chrome developers have indicated that a master password does not provide real security against determined hackers and have refused to implement one.
Bugs filed on this issue have been marked, "Won't fix."
As of February 2014, Google Chrome asks the user to enter their Windows account password before showing saved passwords.
On Linux, Google Chrome/Chromium can store passwords in three ways: genome peering, K-wallet, or plain text.
Google Chrome/Chromium chooses which store to use automatically based on the desktop environment in use.
Passwords stored in genome peering or K-wallet are encrypted on disk, and access to them is controlled by dedicated daemon software.
Passwords stored in plain text are not encrypted.
Because of this, when either genome peering or K-wallet is in use, any unencrypted passwords that have been stored previously are automatically moved into the encrypted store.
Support for using genome peering and K-wallet was added in version 6, but using these, when available, was not made the default mode until version 12.
As of version 45, the Google Chrome Password Manager is no longer integrated with Keychain since the interoperability goal is no longer possible. No security vulnerabilities in Chrome were exploited in the 3 years of TaBNWNE from 2009 to 2011.
At TaBNWNE 2012, Chrome was defeated by a French team who used zero-day exploits in the version of Flash, shipped with Chrome to take complete control of a fully patched 64-bit Windows 7 PC using a booby-trapped website that overcame Chrome's sandboxing.
Chrome was compromised twice at the 2012 Tansic.
Google's official response to the exploits was delivered by Jason Kersey, who congratulated the researchers, noting, "We also believe that both submissions are works of art and deserve wider sharing and recognition."
Fixes for these vulnerabilities were deployed within 10 hours of the submission. A significant number of security vulnerabilities in Chrome occurred in the Adobe Flash Player.
For example, the 2016 TaBNWNE successful attack on Chrome relied on 4 security vulnerabilities.
2 of the vulnerabilities were in Flash, 1 was in Chrome, and 1 was in the Windows kernel.
In 2016, Google announced that it was planning to phase out Flash Player in Chrome, starting in version 53.
The first phase of the plan was to disable Flash for end-to-end background analytics, with the ultimate goal of disabling it completely by the end of the year, except on specific sites that Google has deemed to be broken without it.
Flash would then be re-enabled with the exclusion of ads and background analytics on a site-by-site basis.
Leaked documents from 2015 to 2016 code, named Vault 7, detail the capabilities of the United States Central Intelligence Agency, such as the ability to compromise web browsers, including Google Chrome. Google introduced download scanning protection in Chrome 17.
In February 2018, Google introduced an ad blocking feature based on recommendations from the Interactive Advertising Bureau.
Sites that employ invasive ads are given a 30-day warning, after which their ads will be blocked.
Consumer Reports recommended users install dedicated ad blocking tools instead, which offer increased security against malware and tracking.
Chrome supported up to version 45 plugins with a Netscape plugin application programming interface and the API, so that plugins, for example Adobe Flash Player, run as unrestricted separate processes outside the browser and cannot be sandboxed as tabs are.
ActiveX is not supported.
Since 2010, Adobe Flash has been integral to Chrome and does not need to be installed separately.
Flash is checked up to date as part of Chrome's own updates.
Java applet support was available in Chrome with Java 6 Update 12 and above.
Support for Java under OS X was provided via Java Update released on May 18, 2010.
On August 12, 2009, Google introduced a replacement for NP API that is more portable and more secure, called Pepper Plugin API, PP API.
The default bundled PP API Flash Player or Pepper-based Flash Player was available on ChromeOS first, then replaced the NP API Flash Player on Linux from Chrome version 20, on Windows from version 21.1, which also reduced flash crashes by 20% and eventually came to OS X at version 23.
On September 23, 2013, Google announced that it would be deprecating and then removing NP API support.
NP API support was removed from Linux in Chrome Release 35.
NP API plugins like Java can no longer work in Chrome, but there are workarounds for Flash UI using PP API Flash Player on Linux, including for Chromium.
On April 14, 2015, Google released Chrome v42, disabling the NP API by default.
This makes plugins that do not have a PP API plugin counterpart incompatible with Chrome, such as Java, Silverlight, and Unity.
However, NP API support could be enabled through the Chrome//flags menu until the release of version 45 on September 1, 2015. That removed NP API support entirely.
The private browsing feature, called incognito mode, prevents the browser from locally storing any history information, cookies, site data, or form inputs.
Downloaded files and bookmarks will be stored.
In addition, user activity is not hidden from visited websites or the internet service provider. Incognito mode is similar to the private browsing feature in other web browsers.
It does not prevent saving in all windows. You can switch between an incognito window and any regular windows you have open. You'll only be in incognito mode when you're using the incognito window.
The iOS version of Chrome also supports the optional ability to lock incognito tabs with Face ID, Touch ID, or the device's passcode. In February 2012, Google announced that Chrome would implement the Do Not Track (DNT) standard to inform websites the users desire not to be tracked.
The protocol was implemented in version 23.
In line with the W3's draft standard for DNT, it is turned off by default in Chrome. A multi-process architecture is implemented in Chrome where, by default, a separate process is allocated to each site instance and plugin.
This procedure is termed process isolation and raises security and stability by preventing tasks from interfering with each other.
An attacker successfully gaining access to one application gains access to no others, and failure in one instance results in a sad tab screen of death, similar to the well-known sad Mac, but only one tab crashes instead of the whole application.
This strategy exacts a fixed per process cost up front, but results in less memory bloat over time as fragmentation is confined to each instance and no longer needs further memory allocations.
This architecture was later adopted in Safari and Firefox. Chrome includes a process management utility called Task Manager, which lets users see what sites and plugins are using the most memory, downloading the most bytes, and overusing the CPU, and provides the ability to terminate them.
Chrome version 23 ensures its users an improved battery life for the systems supporting Chrome's GPU accelerated video decoding.
The first production release on December 11, 2008 marked the end of the initial beta test period and the beginning of production.
Shortly thereafter, on January 8, 2009, Google announced an updated release system with 3 channels, stable, corresponding to the traditional production beta. A developer preview, also called the Dev channel.
Where there were before only 2 channels, Data and Developer, now there were 3.
Concurrently, all developer channel users were moved to the Data channel along with a promoted developer release.
Google explained that now the developer channel builds would be less stable and polished than those from the initial Google Chrome's data period.
Maybe users could opt back to the developer channel as desired.
Each channel has its own release cycle and stability level.
The stable channel updated roughly quarterly with features and fixes that passed thorough testing in the Data channel.
Data updated roughly monthly with stable and complete features migrated from the developer channel.
The developer channel updated once or twice per week and was where ideas and features were first publicly exposed and sometimes fail and can be very unstable at times.
Quoted remarks from Google's policy announcements. On July 22, 2010, Google announced it would ramp up the speed at which it releases new stable versions. The release cycles were shortened from quarterly to 6 weeks for major stable updates.
Data channel releases now come roughly at the same rate as stable releases, though approximately 1 month in advance, while Dev channel releases appear roughly once or twice weekly, allowing time for basic release critical testing.
This faster release cycle also brought a 4th channel, the Canary channel, updated daily from a build produced at 9 o'clock UTC from the most stable of the last 40 revisions.
The name refers to the practice of using canaries in coal mines, so if a change kills Chrome Canary, it will be blocked from migrating down to the developer channel, at least until fixed in a subsequent Canary build.
Canary is the most leading-edge official version of Chrome and somewhat of a mix between Chrome Dev and the Chromium snapshot builds.
Canary releases run side by side with any other channel. It is not linked to the other Google Chrome installation and can therefore run different synchronization profiles, themes, and browser preferences.
This ensures that fallback functionality remains, even when some Canary updates may contain release-breaking bugs.
It does not natively include the option to be the default browser, although on Windows and OS X it can be set through system preferences.
Canary was Windows only at first. An OS X version was released on May 3, 2011. The Chrome Data Channel for Android was launched on January 10, 2015. Like Canary, it runs side by side with a stable channel for Android.
Chrome Dev for Android was launched on April 29, 2015.
All Chrome channels are automatically distributed according to their respective release cycles.
The mechanism differs by platform.
On Windows, it uses Google Update. An auto update can be controlled via group policy.
Alternatively, users may download a standalone installer of a version of Chrome that does not auto-update.
On OS X, it uses Google Update Service. An auto update can be controlled via the OS X defaults system.
On Linux, it lets the system's normal package management system supply the updates.
This auto-updating behavior is a key difference from Chromium, the non-branded open-source browser which forms the core of Google Chrome.
Because Chromium also serves as the pre-release development trunk for Chrome, its revisions are provided as source code and buildable snapshots. Are produced continuously with each new commit, requiring users to manage their own browser updates.
In March 2021, Google announced that starting with Chrome 94, in the third quarter of 2021, Google Chrome stable releases will be made every 4 weeks, instead of 6 weeks as they have been since 2010.
Also, Google announced a new release channel for system administrators and browser embedders with releases every 8 weeks.
Releases are identified by four-part version number, for example, 42.0.2311.90, Windows Stable Release April 14, 2015.
The components are major.minor.build.patch.
Major.minor reflects schedule and policy.
Build.patch identifies content progression.
Major represents a product release.
These are scheduled 7 to 8 per year, unlike other software systems, where the major version number updates only with substantial new content.
Minor is usually 0.
References to version X or X.0, for example, 42.0, refer to this major.minor designation.
Build is ever increasing.
For a release cycle, for example, 42.0, there are several builds in the Canary and developer period.
The last build number from developer is checked throughout data unstable and is locked with a major.minor for that release.
Unpatch resets with each build, incrementing with each patch.
The first patch is 0, but usually the first publicly released patch is somewhat higher.
In data unstable, only patch increments.
Chromium and Chrome release schedules are linked through Chromium major version branch point dates, published annually.
The branch points precede the final Chrome developer build initial, released by 4 days, nearly always, and the Chrome stable initial release by roughly 53 days.
Example, the version 42 branch point was February 20, 2015.
Developer builds stopped advancing at build 2311 with release 42.0.2311.4 on February 24, 4 days later.
The first stable release, 42.0.2311.90, was April 14, 2015, 53 days after the branch point. Chrome supports color management by using the system, provided ICC v2 and v4 support on macOS, and from version 22 supports ICC v2 profiles by default on other platforms. Color management is the process of ensuring consistent and accurate colors across various devices, such as monitors, printers, and cameras.
It involves the use of color profiles, which are standardized descriptions of how colors should be displayed or reproduced.
Color management is necessary because different devices have different color capabilities and characteristics.
For example, a monitor may display colors differently than a printer can reproduce them.
Without color management, the same image may appear differently on different devices, leading to inconsistencies and inaccuracies. To achieve color management, a color profile is created for each device involved in the color workflow.
This profile describes the device's color capabilities and characteristics, such as its color gamut, range of colors it can display or reproduce, and color temperature.
These profiles are then used to translate colors between devices, ensuring consistent and accurate color reproduction. Color management is particularly important in industries such as graphic design, photography, and printing, where accurate color representation is crucial.
It helps to maintain color consistency throughout the entire workflow, from capturing an image to displaying or printing it.
Parts of color management are implemented in the operating system, OS, helper libraries, the application, and devices.
The type of color profile that is typically used is called an ICC profile.
A cross-platform view of color management is the use of an ICC-compatible color management system.
The International Color Consortium, ICC, is an industry consortium that has defined
an open standard for color matching module, CMM, at the OS level.
color profiles for
Devices, including device-linked profiles that transform one device profile, color space, to another device profile without passing through an intermediate color space, such as L**, K**, B**, more accurately preserving color.
and working spaces, the color spaces in which color data is meant to be manipulated.
There are other approaches to color management besides using ICC profiles.
This is partly due to history and partly because of other needs than the ICC standard covers.
The film and broadcasting industries make use of some of the same concepts, but they frequently rely on more limited boutique solutions.
The film industry, for instance, often uses 3D lookup table to represent a complete color transformation for specific RGB encoding.
At the consumer level, system-wide color management is available in most of Apple's products, macOS, iOS, iPadOS, watchOS.
Microsoft Windows lacks system-wide color management and virtually all applications do not employ color management.
Windows Media Player API is not color space aware, and if applications want to color manage videos manually, they have to incur significant performance and power consumption penalties.
Android supports system-wide color management, but most devices ship with color management disabled.
Overview. 1. Characterize.
Every color managed device requires a personalized table or color profile, which characterizes the color response of that particular device. 2. Standardize.
Each color profile describes these colors relative to a standardized set of reference colors, the profile connection space. And 3. Translate.
Color managed software then uses these standardized profiles to translate color from one device to another.
This is usually performed by a color management module, CMM. To describe the behavior of various output devices, they must be compared, measured, in relation to a standard color space.
Often a step called linearization is performed first to undo the effect of gamma correction that was done to get the most out of limited 8-bit color paths.
Instruments used for measuring device colors include colorimeters and spectrophotometers.
As an intermediate result, the device gamma is described in the form of scattered measurement data.
The transformation of the scattered measurement data into a more regular form, usable by the application, is called profiling.
Profiling is a complex process involving mathematics, intense computation, judgment, testing, and iteration.
After the profiling is finished, an idealized color description of the device is created.
This description is called a profile.
Calibration is like characterization, except that it can include the adjustment of the device, as opposed to just the measurement of the device.
Color management is sometimes sidestepped by calibrating devices to a common standard color space such as sRGB when such calibration is done well enough. No color translations are needed to get all devices to handle colors consistently.
This avoidance of the complexity of color management was one of the goals in the development of sRGB. Image formats themselves, such as GIF, JPEG, PNG, EPS, PDF, and SVG, may contain embedded color profiles that are not required to do so by the image format.
The International Color Consortium standard was created to bring various developers and manufacturers together.
The ICC standard permits the exchange of output device characteristics and color spaces in the form of metadata.
This allows the embedding of color profiles into images as well as storing them in a database or a profile directory.
Working spaces, such as sRGB, Adobe RGB, or ProPhoto, are color spaces that facilitate good results while editing.
For instance, pixels with equal values of R, G, V should appear neutral.
Using a large, gamut working space will lead to posterization, while using a small working space will lead to clipping.
This trade-off is a consideration for the critical image editor.
Color transformation, or color space conversion, is the transformation of the representation of a color from one color space to another.
This calculation is required whenever data is exchanged inside a color managed chain and carried out by a color matching module.
Transforming profile color information to different output devices is achieved by referencing the profile data into a standard color space.
It makes it easier to convert colors from one device to a selected standard color space and from that to the colors of another device.
by ensuring that the reference color space covers the many possible colors that humans can see. This concept allows one to exchange colors between many different color output devices.
Color transformations can be represented by two profiles, source profile and target profile, or by a device link profile.
In this process, there are approximations involved which make sure that the image keeps its important color qualities and also gives an opportunity to control on how the colors are being changed. In the terminology of the International Color Consortium, a translation between two color spaces can go through a profile connection space, PCS, color space 1 to PCS, CIELAV or CIEXYZ. The color space 2 conversions into and out of the PCS are each specified by a profile. In nearly every translation process, we have to deal with the fact that the color gamut of different devices vary in range, which makes an accurate reproduction impossible.
They therefore need some rearrangement near the borders of the gamut.
Some colors must be shifted to the inside of the gamut, as they otherwise cannot be represented on the output device and would simply be clipped.
This so-called gamut mismatch occurs, for example, when we translate from the RGB color space with a wider gamut into the CMYK color space with a narrower gamut range.
In this example, the dark, highly saturated purplish-blue color of a typical computer monitor's blue primary is impossible to print on paper with a typical CMYK printer.
The nearest approximation within the printer's gamut will be much less saturated.
Conversely, an inkjet printer's CIM primary, a saturated mid-brightness blue, is outside the gamut of a typical computer monitor.
The color management system can utilize various methods to achieve desired results and give experienced users control of the gamut mapping behavior.
When the gamut of source color space exceeds that of the destination, saturated colors are liable to become clipped, inaccurately represented, or more formally burned.
The color management module can deal with this problem in several ways.
The ICC specification includes 4 different rendering intents, listed below.
Before the actual rendering intent is carried out, one can temporarily simulate the rendering by soft proofing.
It is a useful tool as it predicts the outcome of the colors and is available as an application in many color management systems. Absolute colorimetry. Absolute colorimetry and relative colorimetry actually use the same table but differ in the adjustment for the white point media.
If the output device has a much larger gamut than the source profile, that is, all the colors in the source can be represented in the output. Using the absolute colorimetry rendering intent would ideally, ignoring noise, precision, etc., give an exact output of the specified CIELAV values.
Perceptually, the colors may appear incorrect, but instrument measurements of the resulting output would match the source.
Colors outside of the proof print system's possible color are mapped to the boundary of the color gamut.
Absolute colorimetry is useful to get an exact specified color, for example, IBM blue, or to quantify the accuracy of mapping methods. Relative colorimetric. The goal in relative colorimetry is to be truthful to the specified color with only a correction for the media.
Relative colorimetry is useful in proofing applications since it can be used to get an idea of how a print on one device will appear on a different device.
Media differences are the only thing that one really should adjust for, although some gamut mapping also needs to be applied.
Usually this is done in a way where hue and lightness are maintained at the cost of reduced saturation.
By default, in-gamut colors are unchanged, while out-of-gamut colors are clamped. Relative color method is the default rendering intent on many systems. Perceptual. The perceptual intent smoothly moves out-of-gamut colors into gamut, preserving gradations, but distorts in-gamut colors in the process.
Like the saturation intent, the results really depend upon the profile maker.
This is even how some of the competitors in this market differentiate themselves.
The profile maker tries to make results pleasing on this intent.
Perceptual rendering is recommended for color separation. Unsaturation. The saturation intent is designed to present eye-catching business graphics by preserving the saturation color focus.
It is most useful in charts and diagrams where there is a discrete palette of colors that the designer wants saturated to make them intense, but where specific hue is less important.
In practice, photographers almost always use relative or perceptual intent. As for natural images, absolute causes color cast, while saturation produces unnatural colors.
If an entire image is in gamut, relative is perfect, but when there are out-of-gamut colors, which is preferable depends on a case-by-case basis.
CMMs may offer options for VPC and partial chromatic adaptation. A black point correction, VPC, is not applied for absolute color metric or device link profiles.
For ICCV4, it is always applied to the perceptual intent.
ICCV2 sRGB profiles differ among each other in a number of ways, one of which being whether VPC is applied. Color matching module, also method or system, is a software algorithm that adjusts the numerical values that get sent to or received from different devices so that the perceived color they produce remains consistent.
The key issue here is how to deal with a color that cannot be reproduced on a certain device in order to show it through a different device as if it were visually the same color. Just as when the reproducible color range between color transparencies and printed matters are different.
There is no common method for this process, and the performance depends on the capability of each color matching method. Some well-known CMMs are ColorSync, Adobe CMM, Little CMS, and RGLL CMS. Apple's classic macOS and macOS operating systems have provided OS-level color management API'(S) since 1993 through ColorSync.
macOS has added automatic color management, assuming sRGB for most things automatically in the OS, but applications can explicitly target other color spaces if they wish to.
System-wide color management is used in iOS, iPadOS, and watchOS as well. Since 1997, color management in Windows is available through an ICC color management system, ICM, image color management. Beginning with Windows Vista, Microsoft introduced a new color architecture known as WCS, Windows Color System.
WCS supplements the ICM system in Windows 2000 and Windows XP, originally written by Heidelberg.
Apps need to be aware of color management and tag the content appropriately to accurately display colors.
Otherwise, unlike macOS, Windows will display the colors to the maximum extent of the display's gamut, resulting in oversaturated colors on wide gamut displays.
To fix this issue, Microsoft includes a new feature called Auto Color Management since Windows 11 2022. Windows Photo Viewer from Windows 7, also included in later Windows versions, performs proper color management. However, the newer Windows Photos app in Windows 8, 10, 11 does not perform color management until version v 2022.3107.0.26005.0.
Other Windows components, including Microsoft Paint, Snipping Tool, Windows Desktop, Windows Explorer, do not perform color management.
Unfortunately, the vast majority of applications do not use the Windows color system.
For applications that do employ color management, typically web browsers, color management tend to apply for only images and UI, but not videos.
This is because Windows Media Player API is not color space aware.
Thus, browsers, Chrome, Firefox, Edge are only able to do color management for images but not video.
For the same reason, virtually no video players on Windows support color management, including the default Movies and TV app and VLC, with Media Player Classic Home Cinema being a rare exception. On Android, system-wide color management is introduced in Android Oreo 8.1.
However, most Android phones are shipped with color management disabled. Example, adaptive color profile on Google Pixel, vivid color profile on Samsung Galaxy.
This oversaturates sRGB content in a native display gamut, typically DCI-P3.
Users need to manually select the natural color profile to enable color management, enable an accurate display of sRGB and P3 white color content.
Operating systems that use the X Windows system for graphics can use ICC profiles, and support for color management on Linux, still less mature than on other platforms, is coordinated through OpenICC at freedesktop.org and makes use of little CMS. Certain image file types, TIFF and Photoshop, include the notion of color channels for specifying the color mode of the file.
The most commonly used channels are RGB, mainly for display monitors, but also for some desktop printing, and CMYK for commercial printing.
An additional alpha channel may specify transparency mask value.
Some image software, such as Photoshop, perform automatic color separation to maintain color information. In CMYK mode, using a specified ICC profile such as US web-coded SWOP v2.
Adobe software includes its own color management engine, Adobe Color Engine.
It is also available as a separate color management module, Adobe CMM, for use by non-Adobe applications that supports third-party CMMs.
As of 2005, most web browsers ignored color profiles.
Notable exceptions were Safari, starting with version 2.0, and Firefox, starting with version 3.
Although disabled by default in Firefox 3.0, ICC v2 and ICC v4 color management could be enabled by using an add-on or setting a configuration option. As of July 2019, Safari, Chrome and Firefox fully support color management.
However, it is important to note that most browsers only do color management for images and CSS elements, but not video.
Firefox version 3.5, released in 2011, onwards supports ICC v2 tagged images, and version 8.0, released in 2011, adds ICC v4 profile support.
Version 89, released in 2021, and above apply color management to all untagged images and page elements by default.
Internet Explorer support ICC profiles from version 9 onwards, but only converts non-sRGB images to the sRGB profile, regardless of the actual monitor color space.
Google Chrome uses the system, provided ICC v2 and v4 support on macOS, and from version 22, released in 2012. Supports ICC v2 profiles by default on other platforms.
macOS versions of Chrome correctly render video.
Safari has support, starting with version 2.0, released in 2005.
Supports v2 and v4 ICC profiles and correctly renders video.
Opera has support since 12.10, released in 2012, for ICC v4.
And TaBNWNE supported ICC v2 from its first release, and v4 since TaBNWNE 20.2, released in 2015. Regarding mobile browsers, Safari 15.1 on iOS 15.4.1 recognizes the device color profile and can display images accordingly.
Chrome 83 on Android 9 ignores the display profile, simply converting all images to sRGB.
As of 2023, Chrome 114, Android Browser 114 and Firefox for Android 115 support multiple color spaces.
The same is valid for their desktop counterparts. Chrome 118, Edge 114, Safari 16.6, Firefox 117 and Opera 100.
In Chrome, when not connected to the internet and an error message displaying "No Internet" is shown on the top, and 8-bit Tyrannosaurus Rex is shown, but when pressing the space bar on a keyboard, mouse clicking on it or tapping it on touch devices, the T-Rex instantly jumps once and dashes across a cactus-ridden desert, revealing it to be an Easter egg in the form of a platform game.
The game itself is an infinite runner, and there is no time limit in the game as it progresses faster and periodically tints to a black background.
A school Chromebook administrator can disable the game. The Dinosaur game, also known as the Chrome Dino, is a browser game developed by Google and built into the Google Chrome web browser.
The player guides a pixelated T-Rex across a side-scrolling landscape, avoiding obstacles to achieve a higher score.
The game was created by members of the Chrome UX team in 2014. When a user attempts to navigate to a web page on Google Chrome while being offline, the browser notifies the user that they are not connected to the internet, with an illustration of a pixelated Tyrannosaurus Rex shown on the page.
The game can then be launched either by pressing space or up arrow on desktop, or by tapping the dinosaur on Android or iOS mobile devices.
Additionally, the game can be accessed by inputting Chrome column//Vino or Chrome column//network error /106 into the Omnibox. During the game, the dinosaur continuously moves from left to right across a black and white desert landscape, with a player attempting to avoid oncoming obstacles such as cacti and pterosaurs by jumping or ducking.
Pressing space, up arrow, or tapping the dinosaur on mobile devices will cause the dinosaur to leap, while pressing the down arrow key will cause the dinosaur to crouch.
As the game progresses, the speed of play gradually increases until the user hits an obstacle or a pterosaur, prompting an instant game over. Once the player reaches around 700 points, the game switches from dark gray graphics on a white background to pale gray graphics on a black background, representing a shift from day to night, with daytime sky graphics also becoming nighttime sky graphics.
The color scheme then alternates as the game progresses.
The game was designed to reach its maximum score after approximately 17 million years of playtime, in reference to how long the T-Rex existed before it went extinct during the Cretaceous-Paleogene extinction event. If a network administrator disables the dinosaur game, an error message appears when attempting to play the game, which features an image of a meteor heading towards the player character. The game was created by members of the ChromeOS team in 2014, which consisted of Sebastian Gabriel, Alan Betts, and Edward Yoon.
Gabriel designed the player character, named the Lonely T-Rex.
During development, the game was given the code name Project Poem in reference to Mark Poem, the lead singer of the band T-Rex.
The developers chose the dinosaur theme as a reference to the game's function, a joke that not having an internet connection is equivalent to living in the prehistoric ages.
The game was released in September 2014. Initially, it did not work on older devices, so the code was updated and re-released in December of the same year.
The pterosaurs were added as obstacles with a browser update in 2015.
In September 2018, an Easter egg was added to the game in celebration of Chrome's 10th birthday and the game's 4th birthday, with a birthday cake appearing in the desert and a birthday hat appearing on the Lonely T-Rex if the cake is eaten.
In November of the same year, Google introduced a feature to save the player's high score.
The game's source code is available on the Chromium site. In 2021, Google introduced a widget in March for iOS 14, which let players book Chrome column/Veto. A similar widget was introduced to Android later that year.
In July, an Olympic torch Easter egg for the 2020 Tokyo Olympics simulating various Olympic activities was added.
Upon reaching the torch, the Veto transforms into various Olympic games such as swimming, running, and many others.
Instead of the usual cacti and pterosaur obstacles, the Dino now encounters challenges related to the Olympics.
The game received widespread recognition, with creators revealing in September 2018 that approximately 270 million games were played monthly. The dinosaur game is referenced in the Couch Gag opening segment of the season 34 premiere of The Simpsons, Hades Tortoise. In May 2020, a Microsoft Edge update added Surf, a game where players control a surfer attempting to evade obstacles and collect power-ups.
Like the dinosaur game, it is accessible from an error page when the browser is offline, but can also be accessed at the URL column/surf.
The game allows for character customization and multiple control schemes. The same year in August, MSCHF and 100 Thieves partnered to create a modified version of the game, titled Swords, which featured a small arsenal of weapons and time-slowing kills when mismanaged. The weapons could backfire and harm the dinosaur. The current version of Chrome runs on Windows 10 or later.
macOS 10.15 or later.
64-bit versions of Ubuntu 18.04 Plus, Debian 10 Plus, OpenSUSE 15.2 Plus, and Fedora 32 Plus.
Android Oreo or later, Android 10 or later, for 64-bit Chrome.
And iOS 16 or later. As of April 2016, stable 32-bit and 64-bit builds are available for Windows, with only 64-bit stable builds available for Linux and macOS.
64-bit Windows builds became available in the developer channel and as Canary builds on June 3, 2014. In the beta channel on July 30, 2014, and in the stable channel on August 26, 2014.
64-bit OS 10 builds became available as Canary builds on November 7, 2015, in the beta channel on October 9, 2014, and in the stable channel on November 18, 2014. Starting with the release of version 89, Chrome will only be supported on Intel/Intel x86 and AMD processors with the SSE3 instruction set. A beta version for Android 4.0 devices was launched on February 7, 2012, available for a limited number of countries from Google Play. Notable features: synchronization with desktop Chrome to provide the same bookmarks and view the same browser tabs, cached re-rendering, hardware acceleration. Many of the latest HTML5 features, almost all of the web platform's features, GPU accelerated canvas, including CSS 3D transforms, CSS animations, SVG, WebSocket, including binary messages. Dedicated workers, it has overflow scroll support, strong HTML5 video support, and new capabilities such as IndexedDB, web workers, application cache and the file API'(S), date and time pickers, parts of the media capture API.
Also supports mobile-oriented features such as device orientation and geolocation.
Mobile customizations, swipe gesture tab switching, link preview allows zooming in on multiple links to ensure the desired one is clicked, font size boosting to ensure readability regardless of the zoom level. Features missing in the mobile version include sandbox tabs, safe browsing, apps or extensions, Adobe Flash, now and in the future, native client, and the ability to export user data such a list of their open tabs or their browsing history into portable local files. Development changes, remote debugging, part of the browser layer, has been implemented in Java, communicating with the rest of the Chromium and WebKit code through Java native bindings.
The code of Chrome for Android is a fork of the Chromium project.
It is a priority to upstream most new and modified code for Chromium and WebKit to resolve the fork. The April 17, 2012 update included availability in 31 additional languages and in all countries where Google Play is available.
A desktop version of a website can also be requested as opposed to a mobile version.
In addition, Android users can now add bookmarks to their Android home screens if they choose and decide which app should handle links opened in Chrome. On June 27, 2012, Google Chrome for Android exited beta and became stable. Chrome 18.0.1026.311, released on September 26, 2012, was the first version of Chrome for Android to support mobile devices, based on Intel x86. Starting from version 25, the Chrome version for Android is aligned with the desktop version, and usually new stable releases are available at the same time between the Android and the desktop version.
Google released a separate Chrome for Android beta channel on January 10, 2013, with version 25.
As of 2013, a separate beta version of Chrome is available in the Google Play Store. It can run side by side with a stable release. Chrome is available on Apple's mobile iOS operating system as Google Chrome for iOS.
Released in the Apple App Store on June 26, 2012, it supports the iPad, iPhone, and iPod Touch, and the current version requires that the device has iOS 15.0 or greater installed.
In a accordance with Apple's requirements for browsers released through their App Store. This version of Chrome uses the iOS WebKit, which is Apple's own mobile rendering engine and components. Developed for their Safari browser, therefore it is restricted from using Google's own V8 JavaScript engine.
Chrome is the default web browser for the iOS Gmail application.
In a review by Chitika, Chrome was noted as having 1.5% of the iOS web browser market as of July 18, 2012.
In October 2013, Chrome had 3% of the iOS browser market.
On Linux distributions, support for 32-bit Intel processors ended in March 2016, although Chromium is still supported.
As of Chrome version 26, Linux installations of the browser may be updated only on systems that support GCC v4.6 and GTK v2.24 or later.
Thus deprecated systems include, for example, IM6 is 2.20 and RHEL6 is 2.18. Support for Google Chrome on Windows XP and Windows Vista ended in April 2016.
The last release of Google Chrome that can be run on Windows XP and Windows Vista was version 49.0.2623.112. Released on April 7, 2016, then re-released on April 11, 2016.
Support for Google Chrome on Windows 7 was supposed to end upon the announcement on July 15, 2021, and suddenly moved to January 15, 2022. However, due to the ongoing COVID-19 pandemic and enterprises took more time to migrate to Windows 10 or 11, the end of support date was pushed at least until January 15, 2023.
Support for Windows 7, Windows 8, and Windows 8.1 ended in January 2023, and the last version on Windows 7 is Chrome 109.
Windows 8 mode was introduced in 2012 and has since been discontinued.
It was provided to the developer channel, which enabled Windows 8 and Windows 8.1 users to run Chrome with a full-screen, tablet-optimized interface, with access to snapping, sharing, and search functionalities.
In October 2015, Windows 8 mode on the developer channel changed to use a desktop environment mimicking the interface of ChromeOS with a dedicated windowing system and taskbar for web apps.
This was removed on version 49, and users that have upgraded to Windows 10 will lose this feature.
Google dropped support for macOS 10 Leopard with the release of Chrome 22.
Support for 32-bit versions of Chrome ended in November 2014 with the release of Chrome 39.
Support for macOS 10 Snow Leopard, macOS 10 Lion, and OS 10 Mountain Lion ended in April 2016 with the release of Chrome 50.
Support for OS 10 Mavericks ended in April 2018 with the release of Chrome 66.
Support for OS 10 Yosemite ended in January 2021 with the release of Chrome 88.
Support for OS 10 El Capitan and macOS Sierra ended in August 2022 with the release of Chrome 104.
Support for macOS High Sierra and macOS Mojave ended in September 2023 with the release of Chrome 117. Google Chrome is the basis of Google's ChromeOS operating system that ships on specific hardware from Google's manufacturing partners.
The user interface has a minimalist design resembling the Google Chrome browser.
ChromeOS is aimed at users who spend most of their computer time on the web. The only applications on the devices are a browser incorporating a media player and a file manager. Google announced ChromeOS on July 7, 2009. ChromeOS, sometimes styled as ChromeOS and formerly styled as ChromeOS, is a Linux distribution developed and designed by Google.
It is derived from the open-source ChromeOS, based on the Linux kernel, and uses the Google Chrome web browser as its principal user interface.
Google announced the project in July 2009, initially describing it as an operating system where applications and user data would reside in the cloud.
ChromeOS was used primarily to run web applications.
All Chromium OS and Chrome OS versions support progressive web applications, such as Google Docs or Microsoft Office 365.
ChromeOS, but not Chromium OS, from 2016 onwards, can run Android applications from Google Play.
Since 2018, Chromium OS/Chrome OS version 69 onwards also support Linux applications, which are executed in a lightweight virtual machine with a Debian environment. To ascertain marketing requirements, developers relied on informal metrics, including monitoring the usage patterns of 200 machines used by Google employees.
Developers also noted their own usage patterns.
ChromeOS was initially intended for secondary devices like netbooks, and not as a user's primary PC.
Google has requested that its hardware partners use solid-state drives for performance and reliability reasons, as well as the lower capacity requirements inherent in an operating system that accesses applications and most user data on remote servers.
In November 2009, Matthew Papatikos, engineering director for the ChromeOS, announced that ChromeOS would only support solid-state storage, that is, not mechanical hard disks. And noted that ChromeOS only required 1/60th as much drive space as Windows 7.
10 years later, in 2019, the recovery images Google provided for ChromeOS were still only between 1 and 3 gigabytes in size.
On November 19, 2009, Google released ChromeOS's source code as the Chromium OS project.
At a November 19, 2009 news conference, Sundar Pichai, at the time Google's vice president overseeing Chrome, demonstrated an early version of the operating system.
He previewed a desktop, which looked very similar to the desktop Chrome browser, and in addition to the regular browser tabs also had application tabs, which take less space and can be pinned for easier access.
At the conference, the operating system booted up in 7 seconds, a time Google said it would work to reduce.
Additionally, Chris Kenyon, vice president of OEM services at Canonical Limited, announced that Canonical was under contract to contribute engineering resources to the project, with the intent to build on existing open-source components and tools where feasible. Canonical was an early engineering partner on the project, and initially Chromium OS could only be built on an Ubuntu system.
In February 2010, the Chromium OS development team switched to Gentoo Linux because Gentoo's package management system portage was more flexible.
The Chromium OS build environment is no longer restricted to any particular distribution, but installation and quick start guides use Debian's, and thus also Ubuntu's, apt syntax. In 2010, Google released the unbranded CR48 Chromebook in a pilot program.
The launch date for retail hardware featuring Chrome OS was delayed from late 2010 until the next year.
On May 11, 2011, Google announced two Chromebooks from Acer and Samsung at Google I/O.
The Samsung model was released on June 15, 2011, and the Acer model in mid-July.
In August 2011, Netflix announced official support for ChromeOS through its streaming service, allowing Chromebooks to watch streaming movies and TV shows via Netflix.
At the time, other devices had to use Microsoft Silverlight to play videos from Netflix.
Later in that same month, Citrix released a client application for ChromeOS, allowing Chromebooks to access Windows applications and desktops remotely.
Dublin City University became the first educational institution in Europe to provide Chromebooks for its students when it announced an agreement with Google in September 2011.
By 2012, demand for Chromebooks had begun to grow, and Google announced a new range of devices designed and manufactured by Samsung.
In so doing, they also released the first Chromebox, the Samsung Series 3, which was ChromeOS entrance into the world of desktop computers.
Although they were faster than the previous range of devices, they were still underpowered compared to other desktops and laptops of the time, fitting in more closely with a netbook market.
Only months later, in October, Samsung and Google released a new Chromebook at a significantly lower price point, $250, compared to the previous Series 5 Chromebook's $450.
It was the first Chromebook to use an ARM processor, one from Samsung's Exynos line.
To reduce the price, Google and Samsung also reduced the memory and screen resolution of the device.
An advantage of using the ARM processor, however, was that the Chromebook did not require a fan.
Acer followed quickly after with a C7 Chromebook, priced even lower, $199, but containing an Intel Celeron processor.
One notable way Acer reduced the cost of the C7 was to use a laptop hard disk rather than a solid-state drive. In April 2012, Google made the first update to ChromeOS's user interface since the operating system had launched, introducing a hardware accelerated window manager called Aura, along with a conventional taskbar.
The additions marked the departure from the operating system's original concept of a single browser with tabs and gave ChromeOS the look and feel of a more conventional desktop operating system.
In a way, this almost feels as if Google is admitting defeat here, wrote Frederick Lardinos on TechCrunch.
He argued that Google had traded its original version of simplicity for greater functionality.
That's not necessarily a bad thing, though, and may just help ChromeOS gain more mainstream acceptance as new users will surely find it to be a more familiar experience.
Lenovo and HP followed Samsung and Acer in manufacturing Chromebooks in early 2013 with their own models.
Lenovo specifically targeted their Chromebook at students, headlining their press release with Lenovo introduces rugged ThinkPad Chromebook for schools. When Google released Google Drive, they also included Drive integration in ChromeOS version 20, released in July 2012.
While ChromeOS had supported Flash since 2010, by the end of 2012 it had been fully sandboxed, preventing issues with Flash from affecting other parts of ChromeOS.
This affected all versions of Chrome including ChromeOS. Until 2015, Google had never made their own ChromeOS device.
Instead, ChromeOS devices were much more similar to their Nexus line of Android phones, with each ChromeOS device being designed, manufactured, and marketed by third-party manufacturers, but with Google controlling the software.
However, in February 2013 this changed when Google released the Chromebook Pixel.
The Chromebook Pixel was totally different from previous devices.
Not only was it entirely Google branded, but it contained an Intel i5 processor, a high-resolution 2560 by 1700 touchscreen display, and came at a price more competitive with business laptops. By the end of 2013, analysts were undecided on the future of ChromeOS.
Although there had been articles predicting the demise of ChromeOS since 2009, ChromeOS device sales continued to increase substantially year over year.
In mid-2014, Time magazine published an article titled, "Depending on who's counting, Chromebooks are either an enormous hit or totally irrelevant," which detailed the differences in opinion.
This uncertainty was further spurred by Intel's announcement of Intel-based Chromebooks, Chromeboxes, and an all-in-one offering from LG called the Chrome Base.
Seizing the opportunity created by the end of life for Windows XP, Google pushed hard to sell Chromebooks to businesses, offering significant discounts in early 2014. ChromeOS devices outsold Apple Macs worldwide for the year 2020. Since July 2021, ChromeOS's embedded controller was changed to be based on the Google-maintained fork of Zephyr, a real-time operating system. In March 2014, Google hosted a hacking contest aimed at computer security experts called TaBNWNE.
Similar to the TaBNWNE contest, they invited hackers from around the world to find exploits in ChromeOS, with prizes available for attacks.
2 exploits were demonstrated there, and a third was demonstrated at that year's TaBNWNE competition.
Google patched the issues within a week.
Although the Google native client has been available on ChromeOS since 2010, there originally were few native client apps available, and most ChromeOS apps were still web apps.
However, in June 2014, Google announced at Google I/O that ChromeOS would both synchronize with Android phones to share notifications and begin to run Android apps installed directly from Google Play.
This, along with a broadening selection of Chromebooks, laid the groundwork for future ChromeOS development. At the same time, Google was also moving towards the new material design language for its products, which it would bring to its web products as well as Android Lollipop.
One of the first material design items to come to ChromeOS was a new default wallpaper.
Google's material design experiment for ChromeOS were added to the stable version with Chrome 117. Chrome Enterprise, launched in 2017, includes ChromeOS, Chrome Browser, Chrome devices and their management capabilities intended for business use.
Businesses can access the standard ChromeOS features and unlock advanced features for business with a Chrome Enterprise upgrade.
Standard features include the ability to sync bookmarks and browser extensions across devices, cloud or native printing, multi-layered security, remote desktop, and automatic updates.
Advanced features include Active Directory integration, unified endpoint management, advanced security protection, access to device policies and Google Admin Console, guest access, kiosk mode, and whitelisting or blacklisting third-party apps managed on Google Play.
The education sector was an early adopter of Chromebooks, ChromeOS, and cloud-based computing.
Chromebooks are widely used in classrooms, and the advantages of cloud-based systems have been gaining an increased share of the market in other sectors as well, including financial services, healthcare, and retail.
The popularity of cloud computing and cloud-based services highlights the degree to which companies and business processes have become both internet-enabled and dependent.
IT managers cite a number of advantages of the cloud that have motivated the move.
Among them are advanced security, because data is not physically on a single machine that can be lost or stolen.
Deploying and managing cloud-native devices is easier because no hardware and software upgrades or virus definition updates are needed, and patching of OS and software updates are simpler.
Simplified and centralized management decreases operational costs. Employees can securely access files and work on any machine, increasing the shareability of Chrome devices.
Whoa!
Google's Grab-and-Go program with Chrome Enterprise allows businesses deploying Chromebooks to provide employees access to a bank of fully charged computers that can be checked out and returned after some time.
In an early attempt to expand its enterprise offerings, Google released Chromebox for meetings in February 2014.
Chromebox for meetings is a kit for conference rooms containing a Chromebox, a camera, a unit containing both a noise-canceling microphone and speakers, and a remote control.
It supports Google Hangouts meetings, video conferences, and conference calls from User Conference. Several partners announced Chromebox for meetings models with Google, and in 2016 Google announced an all-in-one Chrome base for meetings for smaller meeting rooms.
Google targeted the consumer hardware market with the release of the Chromebook in 2011 and Chromebook Pixel in 2013, and sought access to the enterprise market with a 2017 release of the Pixel Book.
The second generation Pixel Book was released in 2019.
In 2021, there are several vendors selling all-in-one Chrome-based devices.
Google has partnered on Chrome devices with several leading OEMs, including Acer, Asus, Dell, HP, Lenovo, and Samsung.
In August 2019, Dell announced that two of its popular business-focused laptops would run Chrome OS and come with Chrome Enterprise upgrade.
The Latitude 5300 2-in-1 Chromebook Enterprise and Latitude 5400 Chromebook Enterprise were the result of a 2-year partnership between Dell and Google.
The machines come with a bundle of Dell's cloud-based support services that would enable enterprise IT managers to deploy them in environments that also rely on Windows.
The new laptop line delivers the search giant's ChromeOS operating system in a form tailored for security-conscious organizations.
Other OEMs that have launched devices with Chrome Enterprise upgrade include Acer and HP.
With a broader range of hardware available, ChromeOS became an option for enterprises wishing to avoid a migration to Windows 10 before Windows 7 support was discontinued by Microsoft. Laptops running ChromeOS are known collectively as Chromebooks.
The first was the CR48, a reference hardware design that Google gave to testers and reviewers beginning in December 2010.
Retail machines followed in May 2011.
A year later, in May 2012, a desktop design marketed as a Chromebox was released by Samsung.
In March 2015, a partnership with Apple was announced and the first commercial Chromebox was developed. In early 2014, LG Electronics introduced the first device belonging to the new all-in-one form factor called Chrome-based.
Chrome-based devices are essentially Chromebox hardware inside a monitor with a built-in camera, microphone, and speakers.
The Chrome bit is an HDMI dongle running ChromeOS.
When placed in an HDMI slot on a television set or computer monitor, the device turns that display into a personal computer.
The first device, announced in March 2015, was an Asus unit that shipped that November and which reached end of life in November 2020. Chromebook tablets were introduced in March 2018 by Acer with their Chromebook Tab 10.
Designed to rival the Apple iPad, it had an identical screen size and resolution and other similar specifications. A notable addition was a Wacom branded stylus that does not require a battery or charging.
ChromeOS supports multi-monitor setups on devices with a video out port, USB 3.0 or USB-C, the latter being preferable. On February 16, 2022, Google announced the development version of ChromeOS Flex, a distribution of ChromeOS that can be installed on conventional PC hardware to replace other operating systems such as Windows and macOS.
It is similar to Cloud Ready, a distribution of Chromium OS, whose developers were acquired by Google in 2020.
ChromeOS automatic updates are available for 10 years for all Chromebook models manufactured in 2019 and onwards. These updates are for the operating system, browser, and hardware.
Google maintains a web page with their auto-update policy and the end date for all ChromeOS devices manufactured.
Previously, the automatic update period was 8 years and shorter prior to that, although the earlier models had continued to receive updates for longer. Initially, ChromeOS was a pure thin client operating system that relied primarily on servers to host web applications and related data storage.
Google gradually began encouraging developers to create packaged applications and later Chrome apps by employing HTML5, CSS, Adobe Shockwave, and JavaScript to provide a user experience closer to a native application.
In September 2014, Google launched App Runtime for Chrome, ARC, which allowed certain ported Android applications to run on ChromeOS.
Runtime was launched with 4 Android applications: Duolingo, Evernote, SiteWords, and Vine.
In 2016, the second version, ARC++, was introduced, using Linux kernel features, C groups, and namespaces to make containers that can run Android apps in an isolated environment.
As ARC++ removed the need to recompile apps, Google made Google Play available for ChromeOS, making most Android apps available for supported ChromeOS devices.
ARC++ was introduced with Android Marshmallow and upgraded to Android Nougat and Android Pie.
ArcVM launched in 2021 with Android 11 and runs on Android 13, starting with ChromeOS 117.
ArcVM uses virtual machines to enhance the isolation of the Android environment in order to improve security and maintainability. In 2018, Google announced plans for Linux on ChromeOS, also known as Crostini, allowing for desktop Linux applications.
The This capability was released in a stable channel as an option for most machines with Chrome 69 in October 2018, but was still marked as beta.
This feature was officially released with Chrome 91. In 2023, with version 119, Google released Valve Corporation's Steam for Chromebook beta for playing video games on Chromebooks meeting minimum hardware requirements.
Steam for Chromebook was developed under the codename Gorillaz, building off work for SteamOS for the Steam Deck, similarly built using a modified version of Arch Linux, running as a virtual machine.
From 2013 until January 2020, Google encouraged developers to build not just conventional web applications for ChromeOS, but Chrome apps, formerly known as packaged apps.
Whoa!
In January 2020, Google's Chrome team announced its intent to phase out support for Chrome apps in favor of progressive web applications, TaBNWNE, and Chrome extensions instead.
Whoa!
In March 2020, Google stopped accepting new public Chrome apps for the Web Store.
According to Google, general support for Chrome apps on ChromeOS will remain enabled without requiring any policy setting through June 2022.
From a user's perspective, Chrome apps resemble conventional native applications. They can be launched outside of the Chrome browser or offline by default, can manage multiple windows, and interact with other applications. Google integrated a media player into both ChromeOS and the Chrome browser, enabling users to play back MP3s, view JPEGs, and handle other multimedia files without connectivity.
The integration also supports DRM videos.
ChromeOS also includes an integrated file manager, resembling those found on other operating systems, with the ability to display directories and the files they contain from both Google Drive and local storage, as well as to preview and manage file contents using a variety of web applications, including Google Docs and Box.
Since January 2015, ChromeOS can also integrate additional storage sources into the file manager, relying on installed extensions that use the file system provider API.
In June 2010, Google software engineer Gary Kaczmarczyk wrote that ChromeOS would access remote applications through a technology unofficially called Chromoting, which would resemble Microsoft's remote desktop connection.
The name has since been changed to Chrome Remote Desktop and is like running an application via remote desktop services or by first connecting to a host machine by using RDP or VNC.
Initial rollouts of ChromeOS laptops, Chromebooks, indicate an interest in enabling users to access virtual desktops. At Google I/O 2014, a proof of concept showing Android applications, including Flipboard, running on ChromeOS was presented.
In September 2014, Google introduced a beta version of the app runtime for Chrome, Arc, which allows selected Android applications to be used on ChromeOS. Using a native client-based environment that provides the platforms necessary to run Android software.
Android applications do not require any modifications to run on ChromeOS, but may be modified to better support a mouse and keyboard environment.
At its introduction, ChromeOS support was only available for selected Android applications.
In 2016, Google introduced the ability to run Android apps on supported ChromeOS devices with access to Google Play in its entirety.
The previous native client-based solution was dropped in favor of a container containing Android's frameworks and dependencies, initially based on Android Marshmallow. which allows Android apps to have direct access to the ChromeOS platform and allow the OS to interact with Android, contracts such as sharing.
Engineering Director Zella Dragornan explained that ARP had been scrapped due to its limitations, including its incompatibility with the Android Native Development Toolkit, NDK, and that it was unable to pass Google's own compatibility test suite. All Chromebooks, made since 2018, and some earlier models, can run Linux apps.
As with Android apps, these apps can be installed and launched alongside other apps.
Google maintains a list of devices that were launched before 2019, which support Linux apps. Since 2013, it has been possible to run Linux applications in ChromeOS through the use of Crouton, a third-party set of scripts that allows access to a Linux distribution such as Ubuntu.
However, in 2018 Google announced that desktop Linux apps were officially coming to ChromeOS.
The main benefit, claimed by Google of their official Linux application support, is that it can run without enabling developer mode, keeping many of the security features of ChromeOS.
It was noticed in the Chromium OS source code in early 2018.
Early parts of Crostini were made available for the Google Pixelbook via the Dev channel in February 2018 as part of ChromeOS version 66. And it was enabled by default via the beta channel for testing on a variety of Chromebooks in August 2018 with version 69. Google's project for supporting Linux applications in ChromeOS is called Crostini, named for the Italian bread-based starter and has a pun on crouton.
Crostini runs a virtual machine through a virtual machine monitor called CrostVM, which uses Linux's built-in KVM virtualization tool.
Although CrostVM supports multiple virtual machines, the one used for running Linux apps, Termina, contains a basic ChromeOS kernel based on Gentoo, in which it runs containers based on LXD.
In the interest of stability and recovery, no Linux apps run on the virtual machine itself. Any installed Linux user and ecosystem runs in an isolated container, all of which are deployed and managed by the virtual machine.
A Debian container with host system integration is provided by default.
Users can install programs to this installation by using tools like apt within the container, or may grant access to .dev files stored on ChromeOS itself, which are copied and installed to the container.
Users may also individually grant access to individual files or USB devices.
Other distributions can be added using LXD, although not by default integrated with a host system.
ChromeOS is built on top of a Linux kernel.
Originally based on Ubuntu, its base was changed to Gentoo Linux in February 2010.
For Project Crostini, as in ChromeOS 121, Debian 12, Bookworm is the default container base image.
In preliminary design documents for the Chromium OS open source project, Google described the three-tier architecture: firmware, browser and window manager, and system-level software and user-led services.
The firmware contributes to fast boot time by not probing for hardware, such as floppy disk drives that are no longer common on computers, especially netbooks.
The firmware also contributes to security by verifying each step in the boot process and incorporating system recovery.
System-level software includes the Linux kernel that has been patched to improve boot performance.
User-led software has been trimmed to essentials with management by Upstart, which can launch services in parallel, respawn crashed jobs, and defer services in the interest of faster booting.
And the window manager handles user interaction with multiple client windows, much like other X-window managers. ChromeOS includes the Chromium shell, or Crush, which documents minimal functionality such as ping at Crush startup. In developer mode, a full-featured mesh shell, which is supposed to be used for development purposes, can be opened via VT2, and is also accessible using the Crush command shell.
To access full privileges in shell, for example, sudo, a root password is requested.
For some time the default was Chronos in ChromeOS and FacePunch in ChromeOS Vanilla, and later the default was empty, and instructions on updating it were displayed at each login. ChromeOS is partially developed under the open source Chromium OS project.
As with other open source projects, developers can modify the code from Chromium OS and build their own versions. Whereas ChromeOS code is only supported by Google and its partners and only runs on hardware designed for the purpose.
Unlike Chromium OS, ChromeOS is automatically updated to the latest version. On Windows 8, exceptions allow the default desktop web browser to offer a variant that can run inside its full-screen, Metro, shell and access features such as the shared charm, without necessarily needing to be written with Windows runtime.
Chrome's Windows 8 mode was previously a tablet-optimized version of the standard Chrome interface.
In October 2015, the mode was changed on developer channel to offer a variant of the ChromeOS desktop. Early in the project, Google provided publicly many details of ChromeOS design goals and direction, although the company has not followed up with a technical description of the completed operating system. Design goals for ChromeOS user interface included using minimal screen space, like combining applications and standard web pages into a single tab strip, rather than separating the two.
Designers considered a reduced window management scheme that would operate only in full-screen mode.
Secondary tasks would be handled with panels, floating windows that dock to the bottom of the screen for tasks like chat and music players.
Split screens were also under consideration for viewing two pieces of content side by side.
ChromeOS would follow the Chrome browser's practice of leveraging HTML5's offline modes, background processing, and notifications.
Designers proposed using search and pin tabs as a way to quickly locate and access applications.
On April 10, 2012, a new build of ChromeOS offered a choice between the original full-screen window interface and overlapping, resizable windows, such as found on Microsoft Windows and Apple's macOS.
The feature was implemented through the Ash Window Manager, which runs atop the Aura hardware accelerated graphics engine.
The April 2012 upgrade also included the ability to display smaller, overlapping browser windows, each with its own translucent tabs. Browser tabs that can be torn and dragged to new positions or merged with another tab strip, and a mouse enable shortcut list across the bottom of the screen.
One icon on the taskbar shows a list of installed applications and bookmarks.
Writing in CNET, Stephen Shanklin argued that with overlapping windows, Google is anchoring itself into the past, as both iOS and Microsoft's Metro interface are largely or entirely full screen.
Even so, ChromeOS already is different enough that it's best to preserve any familiarity that can be preserved.
In 2016, Google included native COPS support in ChromeOS as an experimental feature that became stable in 2020.
With COPS support turned on, it becomes possible to use most printers, even if they do not support Google Cloud Print.
Google Cloud Print was a Google service that helps any application on any device to print on supported printers.
While the cloud provides virtually any connected device with information access, the task of developing and maintaining print subsystems for every combination of hardware and operating system, from desktops to netbooks to mobile devices, simply isn't feasible.
The cloud service required the installation of a piece of software called Proxy as part of the ChromeOS.
The proxy registered the printer with a service, managed the print jobs, provided the printer driver functionality, and gave status alerts for each job.
Google announced that Google Cloud Print would no longer be supported after December 31, 2020, and that the online service would not be available as of January 1, 2021. ChromeOS was designed to store user documents and files on remote servers.
Both ChromeOS and the Chrome browser may introduce difficulties to end users when handling specific file types offline. For example, when opening an image or document residing on a local storage device, it may be unclear whether and which specific web application should be automatically opened for viewing, or the handling should be performed by a traditional application acting as a preview utility.
Matthew Patrickos, ChromeOS Engineering Director, noted in 2010 that Windows developers have faced the same fundamental problem. QuickTime is fighting with Windows Media Player, which is fighting with Chrome. ChromeOS uses the same release system as Google Chrome. There are three distinct channels: Stable, Beta, and Developer Preview, called the Dev channel.
The stable channel is updated with features and fixes that have been thoroughly tested in the data channel, and the data channel is updated approximately once a month with stable and complete features from the developer channel.
New ideas get tested in the developer channel, which can be very unstable at times.
A fourth canary channel was confirmed to exist by Google developer Francois Beaufort and hacker Kenny Strong by entering the ChromeOS shell in developer mode, typing the command shell to access the bash shell, and finally entering the command update _engine client -channel canary -channel -update.
It is possible to return to the verified boot mode after entering the canary channel, but the channel updater disappears and the only way to return to another channel is using the power wash factory reset. In March 2010, Google software security engineer Will Curry discussed ChromeOS security.
Curry described ChromeOS as a hardened operating system featuring auto-updating and sandbox features that would reduce malware exposure.
He said that ChromeOS netbooks would be shipped with Trusted Platform Module, TPM, and include both a trusted boot path and a physical switch under the battery compartment that activates a developer mode.
That mode drops some specialized security functions that increases developer flexibility.
This switch is also reversible.
Curry also emphasized that the open-source nature of the operating system would contribute greatly to its security by allowing constant developer feedback.
At a December 2010 press conference, Google declared that ChromeOS would be the most secure consumer operating system due, in part to a verified bootability in which the initial boot code, stored in read-only memory, checks for system compromises. ChromeOS devices ship with full disk encryption by default, which cannot be disabled.
The decryption password is stored in the device's TPM.
Google allows the TPM to be updated manually via the settings.
Updating the TPM will reset the device to factory defaults.
ChromeOS devices utilize a user's Google account password as the default sign-in method.
To enhance security, users can implement additional authentication measures such as PINs, passwords, fingerprint recognition, facial recognition, or smart unlock via a paired phone.
These supplementary measures mitigate the risk of unauthorized access to the user's Google account via shoulder surfing, even if an attacker possesses the user's Google email address. If multi-factor authentication, MFA, is enabled on the associated Google account, the user may be prompted to use it during the initial setup of their ChromeOS device.
By default, the device will be designated as trusted, exempting it from MFA requirements for subsequent logins.
For enhanced security, MFA can be mandated for each sign-in by utilizing hardware tokens, such as YubiKeys, linked to the Google account. At its debut, ChromeOS was viewed as a competitor to Microsoft, both directly to Microsoft Windows and indirectly the company's word processing and spreadsheet applications, the latter through ChromeOS reliance on cloud computing.
But ChromeOS engineering director Matthew Papakitos argued that the two operating systems would not fully overlap in functionality because ChromeOS is intended for netbooks, which lack the computational power to run a resource-intensive program like Adobe Photoshop.
Some observers claim that other operating systems already filled the niche that ChromeOS was aiming for, with the added advantage of supporting native applications, in addition to a browser.
Tony Bradley of PC World wrote in November 2009.
We can already do most, if not all, of what ChromeOS promises to deliver. Using a Windows 7 or Linux-based netbook, users can simply not install anything but a web browser and connect to the vast array of Google products and other web-based services and applications. Netbooks have been successful at capturing the low-end PC market, and they provide a web-centric computing experience today. I am not sure why we should get excited that a year from now we'll be able to do the same thing, but locked into doing it from the fourth-place web browser.
In 2016, Chromebooks were the most popular computer in the US K-12 education market. By 2017, the Chrome browser had risen to become the #1 browser used worldwide. In 2020, Chromebooks became the second most popular and user-oriented OS, growing from 6.4% in 2019 to 10.8% in 2020.
The majority of growth came at Windows Expanse, which fell from 85.4% in 2019 to 80.5% in 2021.
Google's offer of several open-source operating systems, of which Android and ChromeOS are the best known, has attracted some criticism, despite the similarity between this situation and that of Apple Incorporated S2 operating systems, macOS and iOS.
Steve Ballmer, Microsoft CEO at the time, accused Google of not being able to make up its mind.
Stephen Levy wrote that the dissonance between the two systems was apparent at Google I/O 2011.
The event featured a daily press conference in which each team leader, Android's Andy Rubin and Chrome's Sundar Pichai, unconvincingly tried to explain why the systems weren't competitive.
Google co-founder Sergey Brin addressed the question by saying that owning two promising operating systems was a problem that most companies would love to face.
Brin suggested that the two operating systems will likely converge over time.
The speculation over convergence increased in March 2013 when ChromeOS chief Pitche replaced Rubin as the senior vice president in charge of Android, thereby putting Pitche in charge of both. The relationship between Android and ChromeOS became closer at Google I/O 2014, where developers demonstrated native Android software running on ChromeOS through a native client-based runtime.
In September 2014, Google introduced a beta version of the app runtime for Chrome, Arc, which allows selected Android applications to be used on ChromeOS. Using a native client-based environment that provides the platforms necessary to run Android software.
Android applications do not require any modifications to run on ChromeOS, but may be modified to better support a mouse and keyboard environment.
At its introduction, ChromeOS support was only available for selected Android applications.
In October 2015, the Wall Street Journal reported that ChromeOS would be folded into Android so that a single OS would result by 2017.
The resulting OS would be Android, but it would be expanded to run on laptops.
Google responded that while the company has been working on ways to bring together the best of both operating systems, there's no plan to phase out ChromeOS. In 2016, Google introduced the ability to run Android apps on supported ChromeOS devices with access to Google Play in its entirety.
The previous native client-based solution was dropped in favor of a container containing Android's frameworks and dependencies, initially based on Android Marshmallow, which allows Android apps to have direct access to the ChromeOS platform and allows the OS to interact with Android, contracts such as sharing.
Engineering Director Zelazrag Warnan explained that ARC had been scrapped due to its limitations, including its incompatibility with the Android Native Development Toolkit, NDK, and that it was unable to pass Google's own compatibility test suite. Google Chrome was met with acclaim upon release.
In 2008, Matthew Moore of the Daily Telegraph summarized the verdict of early reviewers. Google Chrome is attractive, fast, and has some impressive new features.
Initially, Microsoft reportedly played down the threat from Chrome and predicted that most people would embrace Internet Explorer 8.
Opera Software said that Chrome will strengthen the web as the biggest application platform in the world.
But by February 25, 2010, Business Week had reported that, for the first time in years, energy and resources are being poured into browsers, the ubiquitous programs, for accessing content on the web. Credit for this trend, a boon to consumers, goes to two parties. The first is Google, whose big plans for the Chrome browser have shaken Microsoft out of its competitive torpor and forced the software giant to pay fresh attention to its own browser, Internet Explorer. Microsoft all but ceased efforts to enhance IE after it triumphed in the last browser war, sending Netscape to its doom. Now it's back in gear.
Mozilla said that Chrome's introduction into the web browser market comes as no real surprise that Chrome is not aimed at competing with Firefox. And furthermore, that it would not affect Google's revenue relationship with Mozilla.
Chrome's design bridges the gap between desktop and so-called cloud computing. At the touch of a button, Chrome lets you make a desktop, start menu, or quick launch shortcut to any web page or web application, blurring the line between what's online and what's inside your PC. For example, I created a desktop shortcut for Google Maps. When you create a shortcut for a web application, Chrome strips away all of the toolbars and tabs from the window, leaving you with something that feels much more like a desktop application than like a web application or page. PC World.
With its dominance in the web browser market, Google has been accused of using Chrome and link development to push new web standards that are proposed in-house by Google and subsequently implemented by its services first and foremost.
These have led to performance disadvantages and compatibility issues with competing browsers, and in some cases, developers intentionally refusing to test their websites on any other browser than Chrome.
Tom Warren of The Verge went as far as comparing Chrome to Internet Explorer 6, the default browser of Windows XP that was often targeted by competitors due to its similar ubiquity in the early 2000s.
In 2021, computer scientist and lawyer Jonathan Mayer stated that Chrome has increasingly become an agent for Google LLC than a user agent, as it is the only major web browser that lacks meaningful privacy protections by default, shoves users toward linking activity with a Google account, and implements invasive new advertising capabilities.
Since its association with Google, Chrome consistently kept adding features that aren't in the user's best interest in terms of privacy and control, and as a result, it faced criticism over the years. A class action lawsuit seeking $5 billion in damages was filed against Google in 2020 on the grounds it misled consumers into thinking it would not track them when using incognito mode, despite using various means to do so.
In December 2023, a settlement was reportedly agreed to, with public disclosure expected in February 2024.
In June 2015, the Debian developer community discovered that Chromium 43 and Chrome 43 were programmed to download the hot word shared module, which could enable the OK Google voice recognition extension, although by default it was off.
This raised privacy concerns in the media.
The module was removed in Chrome 45, which was released on September 1, 2015, and was only present in Chrome 43 and 44. Chrome sends details about its users and their activities to Google through both optional and non-optional user tracking mechanisms. Some of the tracking mechanisms can be optionally enabled and disabled through the installation interface and through the browser's options dialog.
Unofficial guilds, such as SRware Iron, seek to remove these features from the browser altogether.
The RLZ feature is not included in the Chromium browser either. In March 2010, Google devised a new method to collect installation statistics. The unique ID token included with Chrome is now used for only the first connection that Google Update makes to its server. The optional suggestion service included in Google Chrome has been criticized because it provides the information typed into the omnibox to the search provider before the user even hits return.
This allows the search engine to provide URL suggestions, but also provides them with web use information tied to an IP address.
Chrome previously was able to suggest similar pages when a page could not be found.
For this, in some cases Google servers were contacted.
The feature has since been removed. A 2019 review by Washington Post technology columnist Jeffrey A. Fowler found that in a typical week of browsing, Chrome allowed thousands more cookies to be stored than Mozilla Firefox.
Fowler pointed out that because of its advertising businesses, despite the privacy controls it offers users, Google is a major producer of third-party cookies and has a financial interest in collecting user data. He recommended switching to Firefox, Apple Safari, or Chromium-based Brave.
In 2023, Google proposed a technology that claims to hide the IP and traffic of its users by routing Chrome traffic to Google servers.
This has drawn criticism as all traffic is readily available for Google to use.
Also tied with Google is its advertising business, which given the vast market share of Chrome, sought to introduce features that protects this revenue stream. Mainly the introduction of a cookie tracking alternative, named Federated Learning of Cohorts, FLOC, which evolved into Topics, and Manifest v3 API changes for extension. In January 2021, Google stated it was making progress on developing privacy-friendly alternatives, which would replace third-party cookies currently being used by advertisers and companies to track browsing habits.
Google then promised to phase out the use of cookies in their web browser in 2022, implementing their FLOC technology instead.
The announcement triggered antitrust concerns from multiple countries for abusing the Chrome browser's market monopoly, with the UK's Competition and Markets Authority and the European Commission both opening formal probes.
The FLOC proposal also drew criticism from DuckDuckGo, Brave, and the Electronic Frontier Foundation for misrepresenting its ability to track users online.
On January 25, 2022, Google announced it had killed off development of its FLOC technologies and proposed a new Topics API to replace it.
Topics is similarly intended to replace cookies, using one's weekly web activity to determine a set of 5 interests.
Topics is supposed to refresh every 3 weeks, changing the type of ads served to the user and not retaining the gathered data. Federated Learning of Cohorts, FLOC, is a type of web tracking.
It groups people into cohorts based on their browsing history for the purpose of interest-based advertising.
FLOC was being developed as a part of Google's Privacy Sandbox initiative, which includes several other advertising-related technologies with word-themed names.
Despite federated learning in the name, FLOC does not utilize any federated learning.
Google began testing the technology in Chrome 89, released in March 2021 as a replacement for third-party cookies.
By April 2021, every major browser aside from Google Chrome that is based on Google's open-source Chromium platform had declined to implement FLOC.
The technology was criticized on privacy grounds by groups including the Electronic Frontier Foundation and DuckDuckGo, and has been described as anti-competitive. It generated an antitrust response in multiple countries, as well as questions about general data protection regulation compliance.
In July 2021, Google quietly suspended development of FLOC. Chrome 93, released on August 31, 2021, became the first version which disabled FLOC, but did not remove the internal programming.
On January 25, 2022, Google officially announced it had ended development of FLOC technologies and proposed a new Topics API to replace it.
Brave developers criticized Topics API as a rebranding of FLOC, with only minor changes and without addressing their main concerns.
The Federated Learning of Cohorts algorithm analyzes users' online activity within the browser and generates a cohort ID using the SymHash algorithm to group a given user with other users who access similar content.
Each cohort contains several thousand users in order to make identifying individual users more difficult, and cohorts are updated weekly.
Websites are then able to access the cohort ID using an API and determine what advertisements to serve.
Google does not label cohorts based on interest beyond grouping users and assigning an ID, so advertisers need to determine the user types of each cohort on their own.
Flock experiment was active only in Google Chrome browser and ran from Chrome 89 inclusive, but Chrome 93 not inclusive.
Whoa!
Modern browsers do not support Flock.
While the experiment was active, users could opt out of Flock experiment by disabling third-party cookies.
Website administrators could opt out from cohort calculation via special HTTP headers.
It can be accomplished with a new interest cohort permissions policy or feature policy. The default behavior is to allow cohort calculation.
To opt out of all Flock cohort calculations, a website could send either of the following HTTP response headers.
Permissions-policy, browsing-topics equals parentheses. Or feature-policy, browsing-topics none. Google Chrome applies interest-cohort feature policy restrictions to browsing topics API as well. On August 22, 2019, Google Chrome developers coined the term Flock and first started discussing the upcoming replacement for cookies.
In July 2020, the United Kingdom's Competition and Markets Authority found the Flock proposal to be anti-competitive, since it would place the browser in a vital gatekeeper position for the ad tech ecosystem.
Instead, the authority recommended adoption of a competing proposal called Sparrow, which maintains the same privacy-enhancing objectives but creates a different, completely independent gatekeeper, which does not have any other role in the ad tech ecosystem and does not have access to user-level information. Google began testing Flock in the Chrome 89, released in March 2021 as a replacement for third-party cookies, which Google plans to stop supporting in Chrome by mid-2023.
Initially, Google announced plans to remove third-party cookies by late 2021, then postponed it to early 2022, and then to 2023 due to delay Flock technology.
The initial trial turned on Flock for 0.5% of Chrome users across 10 countries: the United States, Australia, Brazil, Canada, India, Indonesia, Japan, Mexico, New Zealand, and the Philippines.
Users were automatically placed in the trial and were not notified, but could opt out by turning off third-party cookies.
Furthermore, site administrators could disable Flock and opt out from interest calculation via a feature-policy header.
The initial trial did not include users in the United Kingdom or the European Economic Area due to concerns about legality under the area's privacy regulations.
In July 2021, Google suspended development of Flock. Chrome 93, released on August 31, 2021, became the first version, which rendered Flock feature void, but did not remove the internal programming.
Chrome 100, released on March 29, 2022, removed most of old Flock code.
On January 25, 2022, Google officially announced it had ended development of Flock API'(S) and proposed a new Topics API to replace it.
This API would use 3 weeks of the browser's history to identify user interests based on defined topics.
Participating websites could then call this API to get 3 topics, which could be used to tailor advertising.
Developers of the Brave web browser called Topics API a rebranding of Flock without addressing key privacy issues.
Google claimed in January 2021 that Flock was at least 95% effective compared to tracking using third-party cookies, but an exchanger reported that some people in the advertising technology industry expressed skepticism about the claim and the methodology behind it.
As every website that opts into Flock will have the same access about which cohort the user belongs to. The technology's developers say this democratizes access to some information about a user's general browser history, in contrast to the status quo, where websites have to use tracking techniques.
The Electronic Frontier Foundation has criticized Flock, with one EFF researcher calling the testing of the technology in Chrome a concrete breach of user trust in service of a technology that should not exist, in a post on the organization's blog.
The EFF also created a website which allows Chrome users to check whether Flock is being tested in their browsers.
The EFF criticized the fact that every site will be able to access data about a user without having to track them across the web first.
Additionally, on the EFF blog, Cory Doctorow praised Chrome's planned removal of third-party cookies, but added that, just because Flock is billed as pro-privacy and also criticized as anti-competitive, it doesn't mean that privacy and competition are incompatible, stating that Google is appointing itself the gatekeeper who decides when we're spied on while skimming from advertisers with nowhere else to go.
On April 10, 2021, the CEO of DuckDuckGo released a statement telling people not to use Google Chrome, stating that Chrome users can be included in Flock without choosing to be and that no other browser vendor has expressed interest in using the tracking method.
The statement said that there is no such thing as a behavioral tracking mechanism imposed without consent that respects people's privacy, and that Google should make Flock explicitly opt-in and free of dark patterns.
DuckDuckGo also announced that its website will not collect Flock IDs or use them to target ads, and updated its Chrome extension to block websites from interacting with Flock. On April 12, 2021, Brave, a web browser built on the Chromium platform, criticized Flock in a blog post and announced plans to disable Flock in the Brave browser and make company's main website out of Flock.
The blog post, co-written by the company's CEO Brendan Eich, described Google's efforts to replace third-party cookies as Titanic-level deck chair shuffling and a step backward from more fundamental, privacy and user-focused changes the web needs.
Tech and media news site The Verge noted that not all possible repercussions of Flock for ad tech are known, and that its structure could benefit or harm smaller ad tech companies. Noting specifically that larger ad tech companies may be better equipped to parse what Flocks mean and what ads to target against them. Multiple companies including GitHub, Drupal and Amazon declined to enable Flock, instead opting to disable Flock outright by including the HTTP header permissions -policy interest -cohort equals parentheses.
WordPress, a widely used website framework, floated a proposal to disable Flock-based tracking across all websites that use the framework.
Almost all major browsers based on Google's open-source Chromium platform declined to implement Flock, including Microsoft Edge, Vivaldi, Brave, and Opera. In May 2021, The Economist reported that it may be hard for Google to stop the system from grouping people by characteristics they wish to keep private, such as race or sexuality. In May 2021, The Economist said some critics have suggested that the cohort system will facilitate fingerprinting of individual devices, compromising privacy. Wired magazine additionally reported that Flock could be used as a point of entry for fingerprinting. Mozilla, the creators of the Firefox browser, expressed concerns that Flock can be used as an additional fingerprinting vector.
Furthermore, they stated that a user's block group can be tracked during multiple visits and correlated via different means and based on a user's membership in multiple block cohorts. A website might be able to infer information about the user which block aim to keep private.
Since a block cohort is shared across websites, its ID might be used as an alternative to a unique cookie in third-party contexts. In July 2020, the United Kingdom's Competition and Markets Authority found that the block proposal places the browser in a vital gatekeeper position for the ad tech ecosystem. In March 2021, 15 attorneys general of U.S. states and Puerto Rico amended an antitrust complaint filed in December. The updated complaint says that Google Chrome's phase-out of third-party cookies in 2022 will disable the primary cookie tracking technology almost all non-Google publishers currently use to track users and target ads. Then Chrome will offer new and alternative tracking mechanisms, dubbed Privacy Sandbox. Overall, the changes are anti-competitive. In June 2021, EU antitrust regulators launched a formal investigation to assess whether Google violated competition rules with a focus on display advertising. Notably whether it restricts access to user data by third parties while reserving it for its own use.
Among the things that will be investigated is Google's plan to prohibit the placement of third-party cookies and replace them with a privacy sandbox set of tools.
As of April 2021, Google was not testing block in the United Kingdom or the European Economic Area due to concerns about compliance with the General Data Protection Regulation and the e-Privacy Directive. Johannes Kasper, the Data Protection Commissioner of Hamburg, Germany, told Wired UK that block leads to several questions concerning the legal requirements of the GDPR, explaining that block could be seen as an act of processing personal data which requires freely given consent and clear and transparent information about these operations.
A spokesperson of the French National Commission on Informatics and Liberty said that the flock system would require specific, informed and unambiguous consent.
As of April 2021, the Irish Data Protection Commission, which is the lead data supervisor for Google under GDPR, was consulting with Google about the flock proposal. Manifest v3 has faced criticism for changes to the web request API used by ad blocking and privacy extensions to block and modify network connections.
The declarative version of web request uses rules processed by the browser rather than sending all network traffic through the extension, which Google stated would improve performance.
However, declarative web request is limited in the number of rules that may be set and the types of expressions that may be used.
Additionally, the prohibition of remotely hosted code will restrict the ability for filter lists to be updated independently of the extension itself.
As the Chrome Web Store review process has an invariable length, filter lists may not be updated in a timely fashion. Google has been accused of using Manifest v3 to inhibit ad blocking software due to its vested interest in the online advertising market.
Google cited performance issues associated with web request as well as its use in malicious extensions.
In June 2019, it announced that it would increase the aforementioned cap from 30,000 to 150,000 entries to help quell concerns about limitations to filtering rules.
In 2021, the Electronic Frontier Foundation, EFF, issued a statement that Manifest v3 was outright harmful to privacy efforts, as it would greatly limit the functionality of privacy extensions.
In December 2022, Google announced the transition would be paused in order to address developer feedback and deliver better solutions to migration issues.
In November 2023, Google announced it would resume the transition to Manifest v3. Support for Manifest v2 extensions will be removed entirely from non-stable builds of Chrome beginning June 2024.
Other Chromium-based web browsers will adopt Manifest v3, including Microsoft Edge.
Manifest v3 support is being added to Mozilla Firefox's implementation of Chrome's extension API web extensions for compatibility reasons. But Mozilla has stated that its implementation would not contain limitations that affect privacy and content blocking extensions, and that its implementation of v2 would not be deprecated.
Chrome overtook Firefox in November 2011 in worldwide usage.
As of September 2022, according to StatCounter, Google Chrome had 67% worldwide desktop usage share, making it the most widely used web browser.
Along with Safari and Mozilla Firefox, Chrome receives a weekend bump, which boosts its market share by as much as 3 percentage points on weekends, at the expense of Internet Explorer. It was reported by StatCounter, a web analytics company, that for the single day of Sunday, March 18, 2012, Chrome was the most used web browser in the world for the first time.
Chrome secured 32.7% of the global web browsing on that day, while Internet Explorer followed closely behind with 32.5%.
From May 14 to 21, 2012, Google Chrome was for the first time responsible for more internet traffic than Microsoft's Internet Explorer, which won and held its spot as the most used web browser in the world.
According to StatCounter, 31.88% of web traffic was generated by Chrome for a sustained period of 1 week and 31.47% by Internet Explorer.
Though Chrome had topped Internet Explorer for a single day's usage in the past, this was the first time it had led for 1 full week. At the 2012 Google I/O Developers Conference, Google claimed that there were 310 million active users of Chrome, almost double the number in 2011, which was stated as 160 million active users. In June 2015, according to StatCounter, Chrome overtook Internet Explorer for the first time in the US. In August 2015, Chrome was used by 43% of Internet users worldwide.
This study was done by Statista, which also noted that in North America, 36% of people use Chrome, the lowest in the world.
In December 2010, Google announced that to make it easier for businesses to use Chrome, they would provide an official Chrome MSI package.
For business use, it is helpful to have full-fledged MSI packages that can be customized via transform files, .mst, but the MSI provided with Chrome is only a very limited MSI wrapper fitted around the normal installer, and many businesses find that this arrangement does not meet their needs.
The normal, downloaded Chrome installer puts the browser in the user's local app data directory and provides invisible background updates, but the MSI package will allow installation at the system level, providing system administrators control over the update process. It was formerly possible only when Chrome was installed using Google Pack.
Google also created group policy objects to fine-tune the behavior of Chrome in the business environment, for example, by setting automatic updates intervals, disabling auto updates, and configuring a home page.
Until version 24, the software is known not to be ready for enterprise deployments with roaming profiles or terminal server/Citrix environments. In 2010, Google first started supporting Chrome in enterprise environments by providing an MSI wrapper around the Chrome installer.
Google started providing group policy objects, with more added each release, and today there are more than 500 policies available to control Chrome's behavior in enterprise environments.
In 2016, Google launched Chrome Browser Enterprise Support, a paid service enabling IT admins access to Google experts to support their browser deployment.
In 2019, Google launched Chrome Browser Cloud Management, a dashboard that gives business IT managers the ability to control content accessibility, app usage, and browser extensions. Installed on its deployed computers.
In September 2008, Google released a large portion of Chrome's source code as an open source project called Chromium.
This move enabled third-party developers to study the underlying source code and to help port the browser to the macOS and Linux operating systems.
The Google authored portion of Chromium is released under the permissive VSD license.
Other portions of the source code are subject to a variety of open source licenses.
Chromium is similar to Chrome, but lacks built-in automatic updates and a built-in Flash player, as well as Google branding and has a blue-colored logo instead of the multi-colored Google logo.
Chromium does not implement user RLZ tracking.
Initially, the Google Chrome PDF Viewer, PDFEM, was excluded from Chromium, but was later made open source in May 2014.
PDFEM can be used to fill PDF forms.
Chromium is a free and open source web browser project, primarily developed and maintained by Google.
It is a widely used code base, providing the vast majority of code for Google Chrome and many other browsers, including Microsoft Edge, Samsung Internet, and Opera.
The code is also used by several app frameworks. Chromium is a free and open source software project.
The Google authored portion is shared under the free clause BSD license.
Third-party dependencies are subject to a variety of licenses, including MIT, LGPL, MSPL, and an MPL/GPL/LGPL tri-license. This licensing permits any party to build a code base and share the resulting browser executable with a Chromium name and logo.
Thus many Linux distributions do this, as well as FreeBSD and OpenBSD.
Chromium provides the vast majority of source code for Google Chrome, but there are important differences. Chromium lacks the following Chrome features: automatic browser updates,
API keys for some Google services, including Browser Sync,
the Wide-Line DRM module,
licensed codecs for the popular H.264 video and AAC audio formats,
and tracking mechanisms for usage and crash reports. Google first chose the name Chrome for its browser.
Then the open source release was named Chromium because chromium metal is used to make chrome plating.
Chrome has the same user interface functionality as Chromium, but with a Google branded color scheme.
Unlike Chromium, Chrome is not open source. Its binaries are licensed as freeware under the Google Chrome Terms of Service.
The Chromium browser code base contains over 32 million source lines of code, excluding comments and lifelines. Chromium has been a Google project since its inception, and Google employees have done the bulk of the development work. Google refers to this project in the offshoot Chromium OS as the Chromium Projects, and its employees use that chromium.org email address for this development work.
However, in terms of governance, the Chromium projects are not independent entities. Google retains firm control of them.
The Chromium browser codebase is widely used, so others have made important contributions, most notably Microsoft, Mozilla, Yandex, Intel, Samsung, LG, Opera, Vivaldi, and Brave.
Some employees of these companies also have at chromium.org email addresses.
Google designed the first multi-process browser.
Compared to single-process designs, this architecture has better responsiveness, with many browser tabs open and security benefits of process isolation, but with a trade-off of higher memory usage.
This was later refined as per-process website isolation, providing additional security. Another important design decision was for the browser's user interface to be minimalistic. The browser engine was originally based on Apple's WebKit, which Google gave the obvious choice of available options.
However, Google's novel multi-process design required engine changes.
This divergence from Apple's version increased over time, so in 2013 Google officially forked its version as the Blink engine. C++ is the primary language, comprising over half of the code base.
This includes the Blink and V8 engines, the implementation of HTTP and other protocols, the internal tracking system, the extension API, and most of the user interface.
The rest of the user interface, called the Web UI, is implemented in HTML, CSS, and JavaScript, usually via TypeScript translation.
An extensive collection of web platform tests is also written in these languages plus XML.
Third-party libraries that provide essential functionality, such as SQLite and numerous codecs, are written in C, C++, or beginning in 2023, the newer Rust language. Support for mobile operating systems requires special languages, for Android both Java and Kotlin, and for iOS both Objective-C and Swift. Python is the main language of the build system, which also has special configuration files for Google's GN tool. The bug tracking system is a publicly accessible website.
Participants are identified by their email addresses.
The Chromium Continuous Integration System automatically builds and tests the code base several times a day. Builds are identified by a 4-part version number that is major.minor.build.patch.
This versioning scheme and the branch points that occur every 6 to 7 weeks are from Google Chrome and its development cycle.
Google Chrome debuted in September 2008, and along with its release, the Chromium source code was also made available, allowing builds to be constructed from it. Upon release, Chrome was criticized for storing a user's passwords without the protection of a master password.
Google has insisted that a master password provides no real security against knowledgeable hackers, but users argued that it would protect against coworkers or family members. Borrowing a computer and being able to view stored passwords as plaintext.
In December 2009, Chromium developer P. Casting stated, a master password was issue 1397. That issue is closed. We will not implement a master password. Not now, not ever. Arguing for it won't make it happen. A bunch of people would like it won't make it happen. Our design decisions are not democratic. You cannot always have what you want. Version 3 was the first alpha available for Linux.
Chromium soon incorporated native ending for Linux, using the GTK Plus toolkit to allow it to fit into the GNOME desktop environment.
Version 3 also introduced JavaScript engine optimizations and user-selectable themes. Version 6 introduced features for user interface minimalism, as one of Google's goals was to make the browser feel lightweight, cognitively and physically, and fast.
The changes were a unified tools menu, no home button by default, although user configurable, a combined reload/stop button, and the bookmark bar, deactivated by default.
It also introduced an integrated PDF reader, WebM and VP8 support, for use with HTML video and a smarter URL bar. Version 7 boosted performance to twice that of prior versions via hardware acceleration. Version 8 focused on improved integration into ChromeOS and improved cloud features.
These include background web applications, host remoting, allowing users centrally to control features and settings on other computers, and cloud printing.
Version 9 introduced a number of features, including a URL bar feature for exposing phishing attacks and sandboxing for the Adobe Flash plugin.
Other additions were the WebGL library and access for the new Chrome Web Store.
In February, Google announced that it was considering large-scale user interface (UI) changes, including at least partial elimination of the URL bar, which had been a mainstay of browsers since the early years of the web.
The proposed UI was to be a consolidation of the row of tabs and the row of navigation buttons, the menu, and URL bar into a single row.
The justification was freeing up more screen space for web page content.
Google acknowledged that this would result in URLs not always being visible to the user, that navigation controls and menus may lose their context, and that the resulting single line could be quite crowded.
However, by August, Google decided that these changes were too risky and shelved the idea. In March, Google announced other directions for the project.
Development priorities focused on reducing the size of the executable, integrating web applications and plugins, cloud computing, and touch interface support.
Thus, a multi-profile button was introduced to the UI, allowing users to log into multiple Google and other accounts in the same browser instance.
Other additions were malware detection and support for hardware-accelerated CSS transforms.
By May, the results of Google's attempts to reduce the file size of Chromium were already being noted.
Much of the early work in this area concentrated on shrinking the size of WebKit, the image resizer, and the Android build system.
Subsequent work introduced a more compact mobile version that reduced the vertical space of the UI. Other changes in 2011 were GPU acceleration on all pages, adding support for the new Web Audio API and the Google Native Client (NACL), which permits native code supplied by third parties as platform-neutral binaries to be securely executed within the browser itself.
Google's Ski graphics library was also made available for all Chromium versions.
The sync service added for Google Chrome in 2012 could also be used by Chromium builds.
The same year, a new API for high-quality video and audio communication was added, enabling web applications to access the user's webcam and microphone after asking permission to do so.
The and GPU accelerated video decoding for Windows and support for the QUIC protocol were added. In 2013, Chromium's modified WebKit rendering engine was officially forked as the Blink engine. Other changes in 2015 were the ability to reset user profiles and new browser extension API'(S).
Tab indicators for audio and webcam usage were also added, as was automatic blocking of files detected as malware.
Version 67 added the security benefit of per-process website isolation.
Then version 69 introduced a new browser theme as part of the 10th anniversary of Google Chrome.
The same year, new measures were added to curtail abusive advertising. Since 2021, the Google Chrome Sync service can no longer be used by Chromium builds. Starting with version 110, only Windows 10 and later are supported for Windows users. In addition to Google Chrome, many other actively developed browsers are based on the Chromium code. Proprietaries are Arc, Amazon Silk, Avast, Komodo Dragon, DuckDuckGo, Epic, Lex, and Microsoft Edge, Naver Whale, NetFront, Opera, Puffin, Samsung Internet, Sleepner, SRware Iron, UC Browser, and Vivaldi. Primarily non-English. 360 and QQ for the Chinese market.
Cock for the Vietnamese market.
And Yandex for the Russian market. Fossar, Brave, Google, Falcon, Conqueror, Otter, Qt Browser, Supermium, and Google Chromium. These notable app frameworks embed a Chromium browser as the functional core of custom apps. Chromium Embedded Framework, Electron, and Qt Web Engine. The two prominent Chromium-based WebView components also provide a similar way to make apps. Android System WebView and Microsoft Edge WebView 2. With either approach, the custom app is implemented with HTML, CSS, JavaScript, and other web technologies.
Moreover, the app can be readily deployed on the operating systems supported by Chromium.
Since the 2010s, many apps have been created this way.
Two examples are Spotify and Slack.
It is possible to develop applications, extensions, and themes for Chrome.
They are zipped in a .crx file and contain a manifest.json file that specifies basic information such as version, name, description, privileges, etc. And other files for the user interface, icons, pop-ups, etc.
Google has an official developer's guide on how to create, develop, and publish projects.
Chrome has its own web store, where users and developers can upload and download these applications and extensions.
As with Microsoft Internet Explorer, the popularity of Google Chrome has led to the appearance of malware abusing its name.
In late 2015, an adware replica of Chrome named eFast appeared, which would usurp the Google Chrome installation and hijack file type associations to make shortcuts for common file types and communication protocols linked to itself, and inject advertisements into web pages.
Its similar-looking icon was intended to deceive users. That's it for all today. Thank you for watching this episode. Be sure to hit a like, subscribe to our channel with post notifications turned on for more videos as usual, and in the meantime, see you.